A very good evening to all of you. Today, we are going to start with our next topic, that is petroleum. Before that, just kindly confirm if audio and video both are fine. Good, wonderful. So let's begin. So the first topic, so just to give you a recap of the last class, we had started with energy chapter where we understood the basics of what energy means. And then after that, we have started with all the non-renewable sources of energy. And that is where we had discussed about coal. That is where we had stopped. So to begin with, the first topic today would be petroleum, and then after that we'll look at some of the non-conventional non-renewable sources of energy, and then after that, in the second part of our discussion, we'll start with all the renewable sources of energy, where we have solar energy, wind energy, geothermal energy, and biofuels. So these are the things that we are going to discuss in today's class. Now, so the first topic here is petroleum. Now, when it comes to petroleum, we know that petroleum also has been a major part of our energy requirements. We know about coal. We know that coal is required for electricity in India. And then apart from that, there are certain other industries that are also dependent on coal. When it comes to petroleum, petroleum has been a significant part of our transport, right? Whether through petrol or diesel or for many other activities as well, we see that petroleum plays a very, very important role. So, coal and petroleum, these two basically, you can say in a manner, they run the economy. Now, when it comes to petroleum, in case of petroleum, also we know that this is a fossil fuel, just like coal. Just like coal, how it took for coal almost 300 million years. Similarly, for petroleum, also, it might have taken at least 250 million years for the formation to happen. So, in that perspective, these are some of the similarities, that they both are very important energy sources. They both are very, very important for any country's economy. They both are fossil fuels, and they both also contribute a lot to pollution and also to global warming, right? So we know that they all, I mean, there are all these similarities. But when it comes to the science of petroleum versus science of coal, that is where you'll find that they are very different. All right. So, for example, in case of coal, we understood that it is made of only carbon, right? Only made of carbon. Plus, there might be some impurities in it, and that might degrade the quality of coal. On the other hand, when it comes to petroleum, what we know is that petroleum is a complex mixture of hydrocarbons. So we say that it's a complex mixture of hydrocarbons. We'll try to understand what exactly it means. Now, which can occur in any form, whether gaseous form or liquid form or solid form. Now, when it comes to petroleum, so that is where we see that there are certain similarities and there are certain differences, correct? So when it comes to the differences, this is where knowing the differences specifically is very, very important. All right, so let's try to understand how exactly are they different and how exactly are they similar. And it's not very difficult for you to understand. I mean, if we talk about similarities, similarities between coal and petroleum, they both are fossil fuels, right? Strategically important for country's economy. both contribute to pollution and global warming, right? So these are certain similarities that we have between coal and petroleum. Now, what about the differences? What are the differences? Now, when it comes to differences, let's look at certain differences that we have between coal and petroleum. Now, first and foremost, about basically you can say in a manner the origin. The origin, what we know is that, for example, for when it comes to coal, we had discussed that coal formation might have begun in the wetlands, in the marshy areas, in the swamps on land, correct? In the wetland areas on land. So swamps and wetlands. Now, what about petroleum? In case of petroleum, what we know is that petroleum is something where the formation might have begun underwater. So the origin here has been underwater, meaning that it started its formation underwater. So it could be lake beds or sea beds or ocean beds. In most of the cases, seas and oceans, but even the inland lakes, etc., also might have led to the formation of petroleum. Then, in that case, another difference that we see between them is the source. Now, source for coal, we know that it has been vegetation, correct? Source has been vegetation. All the trees and the shrubs, etc., whatever were growing in all these swampy areas, they have contributed to the formation of coal, correct? So source has been basically the vegetation on land, whereas in case of petroleum, that's not the case. In case of petroleum, we see that there might have been both plant and animal based source. All right, it could have been an algae, all right, it could have been algae, it could have been zooplanktons. So both plant and animal based. All right, so algae, so that's why sea and ocean based animals and plants, they both have contributed to petroleum formation, whereas for coal formation only vegetation on land or in the marshy areas would have contributed. So in a manner, coal is veg and petroleum could be non-veg. So that's the basic difference between coal and petroleum. Then another difference that we see is the composition. So composition wise, coal, we know that coal is carbon, right? Coal is carbon plus impurities. So I'm not writing impurities here. Coal is basically supposed to be carbon, and there are certain impurities that might have mixed with it over time. Now, overall, when it comes to petroleum, petroleum is said to be a complex mixture of hydrocarbons. Hydrocarbons. What is hydrocarbon? We'll just discuss this. So, made of complex mixture of hydrocarbons. And then lastly, I mean, something that is very well known, the state. We know that coal is in the solid state, whereas petroleum could be solid, could be liquid, or could be gaseous. All right. So it could be solid, liquid, or gaseous. So that's why state wise also we see that there's a difference. So when you look at the science side of it, that is where you see that they are different. Otherwise, the other factors, we see that there are similarities between them, and that's why they're often counted as often counted together. And one major thing, I mean, very well known, but I missed it. They both will be called as non-renewable. Both will be called as non-renewable, right? So in this manner, we see that there are certain similarities and there are certain differences when it comes to coal and petroleum. All right. So now when we talk about petroleum, we are saying that petroleum is a complex mixture of hydrocarbons, right? We are saying that it's a complex mixture of hydrocarbons. So what do we mean? What's the basic meaning of complex mixture of hydrocarbons? What do we mean by a hydrocarbon? So the name basically gives you a hint that you are talking about an organic compound. Organic compound meaning carbon based compound. Organic compounds, basically these are carbon based compounds. Hydrocarbon, so hydrocarbon where you have only carbon and only hydrogen, where you have any compound, any matter, any kind of material that has only carbon and only hydrogen. Apart from hydrogen and carbon, it does not have anything else. Then in that case, it will be called as a hydrocarbon. Now here we are saying that it's a complex mixture of hydrocarbons. So complex mixture, but when we say complex mixture, the meaning is that here you might have a lot of different types of hydrocarbons which are really mixed together. So that's why you cannot assign a chemical formula to petrol or a chemical formula to diesel, because these are complex mixtures. So there is no guarantee what exactly could be the chemical composition. There will be a mixture of all these hydrocarbons. Whereas when it comes to a compound, it's a mixture. Remember that we are saying that it's a mixture or a complex mixture. Complex mixture because there are multiple different types of hydrocarbons that are present here, uh, and they are mixed together. So it's a very complex mixture of all these hydrocarbons mixed together. Whereas in case of any compound, like let's say water, carbon dioxide, you assign a chemical formula to it, H2O, CO2 and all that, correct? But in this case we are saying it's a complex mixture because there are n number of different types of hydrocarbons that could be mixed in any kind of petroleum product. So that's why we say that it's a complex mixture of hydrocarbons. So complex, I'm just noting it out here. So complex mixture because has many different hydrocarbons could be mixed together in a petroleum product. All right. So that is basically how we talk about petroleum, how we see petroleum. So often we see that we restrict this petroleum to its liquid form, which is called as crude oil. Now, crude oil is, you can say, the raw petroleum. All right. It's a raw petroleum. And from this crude oil, we get all these different types of petroleum, whether it is diesel or petrol or kerosene or jet fuel or naphthalene. All these things are, or even paraffin, wax, etc. They're all the things that we get from this crude oil. So crude oil basically is a mixture of all these different types of petroleum product. And now what we need to do is that we need to separate them out. We need to separate them out, and to separate them we basically use a method that is called as fractional distillation. But how exactly we do that, we'll just have a discussion on that. But before that, let's also talk about how the formation of petroleum happens. Very similar to what we discussed about coal, the entire process is very similar. So first and foremost, the formation here also would have began from these organic material like underwater plants and animals. Now they might have gotten submerged under the seabeds or the ocean beds, and while getting submerged, they would have mixed with all the sediments. And as they get submerged, they obviously are going to get uh, uh, a lot of, they are going to get subjected to a very high temperature and very high pressure. So under these conditions of high pressure and high temperature, there also a chemical uh, deformation, or in a manner you can say a chemical change would have started in these organic material. And that is where the formation of something called as kerosene first takes place. First and foremost, they convert into something called as kerosene. So kerosene basically you can say is an intermediate stage between that plant or the animal and the final petroleum product. So between the two, the intermediate stage that we have is called as kerosene. So in case of kerogen, you can say in a manner is nothing but the in process of change of the organic matter into petroleum. So first the formation into kerogen happens. Then there is a process called as catagenesis. All right. There's a process called as catagenesis, and this takes place next. This is something that takes place next. So basically, when it comes to catagenesis basically is the breakdown of the carbon chains. Now understand what I'm saying. In any organic molecule or any hydrocarbon that we have in these mixtures, there could be hydrocarbons which have very long chains of carbon atoms, meaning that the chemical formula of these hydrocarbons could be C80, C90, etc., meaning that in that compound there are 60, 80, or even 100 carbon atoms and they basically form a chain like structure. Now, in catagenesis, these longer chains of organic molecules, they start breaking down into smaller chains of molecules. All right. So from 80 odd or 90 odd carbon chain, you might see smaller carbon chains of just 10, 20, 15, 8, 7, etc. So that breakdown in from longer carbon chains into shorter or smaller carbon chains is called as catagenesis. So then that's why the next process here is catagenesis. And then after that, so first and foremost, the organic molecule, sorry, I mean the plant or the animal, it gets submerged underwater, under the sea beds or the lake beds, and then from there on they mix with the sediments. They are subjected to high temperature and pressure. Their organic conversion or chemical conversion starts. They convert into first something called as a kerogen. From kerogen, now the breakdown of the carbon chains happen. They start to disintegrate into smaller pieces. So that's the next step. Once that has happened, then there is the last process, which is called as pyrolysis. The last process is called as pyrolysis. Now, this pyrolysis basically is nothing but a thermochemical decomposition of any material in the absence of oxygen. All right. So in the absence of oxygen, so first and foremost, obviously, because you are submerged under the seabeds or the ocean bed, so obviously the oxygen supply has been cut off. So there is no oxygen, and now there is a thermochemical decomposition. Thermochemical. Therm. Do you know what the term therm is often associated with? How do we what do we associate the term therm with? Yes, absolutely. Heat, correct? As many of you have mentioned, heat. So when we say thermochemical decomposition, it means that there is a decomposition, a chemical decomposition of the material happening at high temperature in the absence of oxygen. That's called as pyrolysis. So that's why these three terms, these three processes are the key processes to the formation of petroleum from the organic molecule that was of the plant or the animal. Understood? So first and foremost, basically it is you have kerogen first. So what is kerogen? Kerogen is organic molecule which is an intermediate stage between the organic material and petroleum, right? So this is basically called as kerogen. Now after that, so I'm just writing one more thing here. It is often found as sedimentary rocks. All right. Then after that we have catagenesis. So catagenesis is nothing but the breakdown of long carbon chains to shorter ones. So this is called as catagenesis. And then finally we have pyrolysis. So what is pyrolysis? Pyrolysis is the thermochemical decomposition of a material in the absence of oxygen. So this is called as pyrolysis. So this is how, so all these processes together, they will lead to the formation of petroleum finally. Now, what I told you is that this petroleum that we get, this petroleum product that we get it in the form of crude oil, right? We get it in the form of crude oil. Now, this crude oil is a mixture of all the petroleum products, petrol, diesel, kerosene, etc. They are all mixed in this crude oil, and we need to get these products out of it. All right, we need to get these products out of it. So for that, we use a process which is called as fractional distillation. All right, it is called as fractional distillation. Now, when it comes to fractional distillation, understand what exactly do we do here. Now, distillation is a process that we often use whenever you have to separate two liquids, two miscible liquids, meaning when two liquids they mix in one another. If you want to separate them, then in that case, distillation is the process that we'll have to use. So, for example, if let's say you simply mix water in milk, so milk and water are not directly separable, then in that case, you will have to think of another process. Similarly, let's say a lot of organic compounds, a lot of organic liquids, when they mix in water, they are completely miscible. They would completely mix with water. So that is how basically we see that if you have to separate out these two mixtures, then you will have to use another method. So what we do is that in case of distillation, distillation will be used when you have two liquids which have different boiling points and are miscible liquids, meaning that they can mix in one another but they have different boiling points. So then in that case, distillation is the process that we would use in such a case. So distillation is used to separate miscible liquids with different boiling points. All right, used to separate miscible liquids with different boiling points. So that is where we use distillation. As I told you, that an organic liquid with water. So for example, I've heard that alcohol, if you try, you can mix water in alcohol and you'll not be able to then separate them out, right? If it was oil in water, then you know that they basically form layers, that oil would form a layer over water. But in case of alcohol and water, I have heard that it basically can be mixed very easily without you having to separate it out directly, correct? So that is where we see that distillation as a process you'll have to use if at all you want to separate it. So what happens is that the organic liquids, in general, any organic liquid, you'll see that organic liquids have lower boiling point compared to water. Water would have a boiling point of 100 degrees Celsius. Organic liquids often would have a boiling point of 40 to 60 degrees Celsius. So 50 to 60 in general, you can say. All right. So because of that, they can very easily they will start boiling first. So that is how we use distillation, that you take this mixture and you start heating it. And what we do is that as we, let's say, raise the temperature to, like, let's say 70 degrees Celsius. So by the time you are at 70 degrees Celsius, water would have started heating up, but the second organic liquid, it would have already started to or it would have converted into its gaseous form, like a steam of it. And then that will be uh, taken out of this mixture, and then you would just cool it to get it separately. That's it. And then as you keep on raising the temperature, this is where water would eventually also start to boil. Now, fractional distillation as a process is used whenever the difference in the boiling points is not that great. Meaning, if the difference in the boiling point is like just 10 degrees or 15 degrees or maybe up to 25 degrees Celsius, then in that case, we cannot use this direct method of heating. Then in that case, we use an indirect method which is called as fractional distillation. So in case of fractional distillation, basically what we do is that if you look at this picture, what we basically do is that first we would take this crude oil and we would heat it to a temperature which is very high temperature, where all the parts or all the fractions of this crude oil, they are all in their gaseous form, in their vapor form. So we first just heat it above 400 degrees Celsius, and then we start to cool it down slowly. Slowly we'll start to cool it down, and we'll see that one by one we'll start getting all these fractions, we'll start getting all these different types of petroleum one by one. So that is basically what happens, that at 400 degrees Celsius first you'll get lubricating oil, paraffin wax, asphalt, etc. And then as you keep on decreasing the temperature, you'll keep getting all the different types of petroleum. So that is basically when fractional distillation is used. So fractional distillation is something that we will used when the difference in the boiling points of the liquids or fluids is generally less than 25 degrees Celsius. All right. So when the difference in the boiling points of the liquids or the fluids, if it is less than 25 degrees Celsius, then in that case, fractional distillation as a process would be preferred. All right. So this is basically what we do. All right. This is basically what we do, that fractional distillation will be used when the difference in boiling points is very less, and normal distillation process would be used when the difference in the boiling points is good enough. All right. So this is how this process of distillation or fractional distillation will be used, and this is how we get all the different types of petroleum products. Now, apart from coal and petroleum, there are some other non-renewable sources as well, which are non-conventional sources. Now, why we are saying that these are non-conventional and non-renewable sources? Non-renewable, obviously, because they are in a very limited uh, quantity. They are available in a limited quantity. That's why we are saying that they are non-renewable. But at the same time, they are also non-conventional because they are kind of newer sources of energy. These are sources of energy that we haven't known about traditionally. That's why conventionally we haven't known about them and we haven't used them. So that's why these are called as non-conventional and non-renewable sources, where the first source here is shale. Now, when it comes to shale, what we see is that shale is something that we get from a layer. Basically, this is a layer of shale rocks. This is a layer of shale rocks, and we basically drill a well to this layer. All right, we'll drill a well to this layer, and once we have gone to this layer, this is where we also start drilling horizontally. We start drilling horizontally. Now, as we drill horizontally, this is where cracks are produced. Cracks are produced in this layer, and that is where we have a lot of trapped gas, which is called as the shale gas. All right, this is basically what uh, makes shale. These are also hydrocarbons, largely methane and ethane, but these are basically trapped in this layer of rocks, and these rocks are called as shale rocks, and that's why the gas that we are extracting from there is called as the shale gas. All right, so this is basically how the formation of, or rather the extraction of a shale gas happens. Now shale, when it comes to shale, why we are saying that this is uh, an unconventional source? All right, we are saying that this is a non-conventional and non-renewable, right? Non-conventional and non-renewable. Non-conventional and non-renewable. Now this basically is a newer source, as I told you. First it was US, and US found that they have large deposits of shale. Just imagine the amount of shale resources that they have found is so high that US, before the discovery of shale, used to be a net importer of energy, and from there on they started to become a net exporter of energy. They used to buy energy because they had a deficit of energy as per their requirements. But then after the discovery of shale, and when they found that they have such a huge deposit of shale, that is where from being a net importer they started becoming a net exporter of energy. So that's the difference that has come here. And so US was the country that found it, and then others also. I mean, you can see in a manner a natural justice was done by God, and then Russia also found a lot of shale. So there is a balance, that Russia also has shale, so US also has shale, and China also has shale. So that's why the world is relatively at peace. World is not at peace, I can't say that, but all these powers basically they were able to find sources of shale. So this basically became a non-conventional, non-renewable source of energy. Now, when it comes to shale resources in India, there are certain locations that has been marked in India as well, where we did find certain sources, and we did find uh, 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 certain potential promises. So if you see all these areas which are marked in kind of purple, these are the areas where we have proven shale resources in Assam basin, in Krishna Godavari basin, in Kaveri basin, and in the Kambe basin. These are the areas where it has been proven that India also has shale resources. And then all the orange areas are the areas where we have potential. These are the potential sites of shale resources in India. Now, although, and this map basically was published by ONGC. Now, when it comes to ONGC basically did a research. It did a lot of studies in India, and between 2011 to 2021, between 2011 to 2021, they did a lot of research in looking at all these different sources of shale. But then ultimately they said that we don't see a big promise. The shale resources that India has, it's not at all comparable to what China has, or US has, or Russia has. So we cannot count shale as a big source for us. We cannot look at it as an alternate source. We can, yes, see it as a small additional source. Perhaps we'll start extracting energy from here, but the promise is not that great, and that's why we cannot be dependent on it as a future source of energy, is something that they had said. Although there is a pilot project that also they started running, but ultimately they said that we are not really hopeful with regards to shale in India. The source is very weak and very less. Now, overall, with shale extraction, there are issues that we see. So, for example, it increases the consumption of fresh water, because the drilling that we do, with the drilling, we basically send water at high pressure. It's called as hydraulic pressure. So, high hydraulic pressure, and uh, uh, ultimately what we see is that the fractures that we cause it through this water at high pressure. All right, the hydraulic fracture, that's what also called as hydraulic fracture. So ultimately, the drilling that is done, their water at very high pressure will be sent, so that you can create those cracks in the shale layers. So the consumption of fresh water is very high. Then it can even lead to increased seismicity, or meaning increase in kind of earthquake kind of scenarios, because ultimately you are creating an imbalance inside the earth, so a kind of an instability inside the earth, and that can also contribute to these kind of issues. Then potential ground and water surface water contamination is also possible, because ultimately you are using water, and this water might go and mix with the water bodies, underground water bodies especially. And because this fresh water is not just fresh water, but also is added with certain additives, certain chemicals, and that also pollutes the water. And then there can be a lot of local impacts, because these are new sources of energy. You have to understand this, that any country, when they find a new source of energy, they're not going to let go of that source of energy. They are going to potentially use that energy as much as possible for them. So for the people who have been living in those kind of areas traditionally, it is going to cause a lot of problems for them. A lot of machinery movement and transportation, etc., all of a sudden will start happening, and that's not good for anyone who has been living there. So that's why there are all these local impacts also that it can create. So that's why with shale we do see uh, ultimately uh, we do see that these are certain issues that we see. Now, apart from that, there is another unconventional source, and this is called as coal bed methane. Now, in case of coal bed methane, this is methane that can be extracted from coal beds, or wherever you have the coal mines. Many a times nearby those areas, we see that methane can be extracted from there, and you can use that methane as a source of energy. So that's why it is called as coal bed methane. Now, in case of coal bed methane, we see that the drilling requirements are not that high. It's easier to get this as a source, and India also has been trying. If you look at this particular map, what you basically see is that there are red colored areas and there are yellow colored areas that have been marked. Right, there are red color areas and there are yellow colored areas. So red colored areas are the coal fields, wherever we have the coal resources or the coal mines, and near them you'll see that there are so many areas that have been marked in yellow, and these are the areas where coal bed methane blocks also have been identified. So coal bed methane extraction will happen from these kind of areas, and India basically is also looking to increase its production of coal bed methane and add coal bed methane as an additional source of alternative energy. So that's why we see that there are all these things that we have been working on, and coal bed methane also gets added to all these mix of all these additional sources. The coal ministry also has said that they'll be actively trying to extract coal bed methane wherever it is possible. Otherwise, all that methane gets wasted, which is not good, because we know that we can use this as a source of energy. Now, after this, we have methane hydrate. Now, when it comes to methane hydrates, what do we mean by hydrate? First of all, what do we mean by hydrate? Water, right? So wherever you have molecules of water, any compound with molecules of water, all right? So any compound with molecules of water will be called as a hydrate. So there is a very simple example in our daily lives of a hydrate that we use. Because see, when it comes to hydrates, it does not mean that it has to be liquid. You can see here that what you see in the picture, it's a solid form, correct? So hydrate, even at room temperature, does not mean that if it's a hydrate at room temperature, it will be a liquid. There's an example, a very simple example that I'm sure that every one of us have been using, of a hydrate molecule in our homes. Can you give me the example? Otherwise, I'll give you. What is the hydrate molecule that we are using in our daily life? Salt is a crystal, not exactly. Soap in a manner, you can say, but a better example would be washing powder. Washing powder, just go and look at the chemical formula for washing powder. You'll see that washing powder basically has water molecules in it. So it's not that because of having water molecules, it's not that it's in liquid state. Just that when you mix with water, it will simply mix. Otherwise, it is something which is a hydrate molecule. So that's why, just remember, why I'm giving this example is simple, that I don't want you to imagine that if it's hydrate at room temperature, it will be liquid. Not entirely the case always. Now, when we say methane hydrate, means that this is a hydrate structure, a compound that has methane and water molecules mixed. Now, that is basically where we can get we can get methane from, and we can use this methane also as a source of energy. We can use this methane as source of energy, and we have found various areas, we have marked various areas in the world where we see the deposits of methane hydrates. So for example, along the continental margins, if you see, along the continental margins everywhere we have found deposits of methane hydrates. Apart from that apart from that, the Arctic and the Antarctic areas, the Arctic permafrost and the Antarctic areas. So Arctic and Antarctic areas, they basically have methane hydrate deposits, plus all the sedimentary deposits along the continental margins, and then also deep water sediments of inland lakes and seas. So in those all areas also we have found the traces, or you can say deposits, of methane hydrates. So these are the four areas: Arctic, Antarctic, continental margins, and inland lakes and seas. These are the areas where deposits of methane hydrates have been found. Now, in case of methane hydrates, there is one very interesting fact that we need to know, and that is basically from environmental perspective. And interestingly enough, a question already has been asked in your paper. Read this question. I'm launching the poll for you. Please mark your answer. All right. So I see that it's very distributed, that 31% of you have marked A, 18% B, 18% C, and 32% D. So let me explain what exactly it says here. Which of the following statements are correct about the deposits of methane hydrate? First, global warming might trigger the release of methane gas from these deposits. Global warming. Now, can this happen? The answer is yes, it can happen. So, and it has been happening. So, what we see is that there are methane deposits that we have in the Arctic and the Antarctic areas. And we know that because of global warming, polar ice caps are melting, and because of melting of polar ice caps, methane that was buried deep under, you can say in a manner, it was buried deep under this ice. Now that this ice is melting, because of melting of this ice, what happens is that this methane comes on the surface, and it basically goes and mixes with the atmosphere. So as it mixes with the atmosphere, obviously methane is a greenhouse gas. Remember that methane is a greenhouse gas, and because it's a greenhouse gas, what simply happens is that it contributes more to global warming, because ultimately the source of global warming are all the greenhouse gases, and methane is one of the most potent of greenhouse gases. It is even worse than carbon dioxide as a greenhouse gas. So that's why global warming might trigger the release of methane gas from these deposits. That's correct, that because of global warming the polar ice caps are melting, and that is leading to more methane going and mixing with the atmosphere, and hence contributing even more to global warming. So that is basically what's happening. So that's the first is correct. Second is large deposits of methane hydrate are found in Arctic tundra and under the sea floor. This is correct. We discussed that Arctic tundra, sea floor, continental margins, and Antarctic areas. These are the four areas. So second is correct. Third statement. Methane in atmosphere oxidizes to carbon dioxide after a decade or two. Now, even this statement is correct. So ultimately what happens is, see that methane is not that reactive that it will quickly react, but when given time we see that ultimately it does react with oxygen that's there in the atmosphere and converts to carbon dioxide. So something like this happens, that you have methane, that is CH4, it reacts with oxygen to form carbon dioxide and moisture or water. If you're also a big fan of balancing the equation, then do this. So this is the reaction that happens ultimately, and this reaction basically happens, how exactly what we see is that ultimately it would take some time. Usually we say that it takes 8 to 12 years. Usually we see that it takes at least 8 to 10 12 years, and then in that case we see that methane would react with oxygen in the atmosphere to form carbon dioxide and water or moisture. So in this manner we see that this is how uh, this happens. So that's why even this statement is correct, and the correct statement here, that's why, would be 1, 2 and 3. All right, all these three statements given here are correct. Then lastly we have HCNG. Now in case of HCNG, it is where we are mixing hydrogen with CNG. Now what is CNG? CNG is compressed natural gas. So compressed natural gas, we know that it is something, CNG is something that we use as fuel, as a replacement for petrol, diesel, or even for LPG. So instead of all these petroleum sources, we can make the use of compressed natural gas, that is CNG, which is primarily methane. Wherever you see natural gas, always remember that whenever we are talking about natural gas is nothing but methane. Largely it is methane. All right. Natural gas is largely methane. So that's why wherever you find the term natural gas in any form, just know that there it's methane that they are discussing. So hydrogen enriched compressed natural gas. Now HCNG. So now why HCNG? Because CNG, we know that CNG is a cleaner fuel, correct? Compared to petrol, diesel, even LPG, it's a better fuel, it's a cleaner fuel. And that is the reason why CNG is used so much. That we see that in the Delhi NCR region, especially, CNG is used, and there are other places, of course, in India as well, where CNG is being used. Now, in this case, in CNG, we are adding hydrogen. We are adding hydrogen to it. Now, why hydrogen? So, when we talk about hydrogen, what's the advantage, or what are the advantages of hydrogen? First thing is that hydrogen is very abundant. So, first advantage is the abundance of hydrogen. Hydrogen in its elemental form is the 10th most abundant element on the earth. But there are so many different forms in which hydrogen is present. Water. It has hydrogen. All the hydrocarbons that we discussed, it has hydrogen. So there are so many things where hydrogen actually can be extracted from. So that's why hydrogen abundance is one of the biggest advantages that hydrogen has. Then apart from that, it is clean. Hydrogen is a clean source of energy. There's no carbon dioxide emission, there is no greenhouse gas emission and all that. So that's why from that perspective, hydrogen is clean. So that's the second advantage that it brings, that it is cleaner than CNG, it is cleaner than other fuels that we often are using. So that's why hydrogen. So that's the second advantage that hydrogen gives. And then it has high efficiency. It has high efficiency. So that's another advantage that hydrogen gives. So that's the reason because why we want to use hydrogen, because it is very abundant, it is a very clean source of energy, and it is very highly efficient. And that is the reason why we want to use hydrogen. And that's why in a manner you can say that hydrogen becomes renewable, closer to renewable, right? In a manner you can say that hydrogen becomes closer to being renewable. So that also adds to the advantage, and that is why HCNG. That is why HCNG. Now with HCNG, we see that it will be able to reduce the emissions of carbon monoxide, enables fuel savings. Then after that, the engines can be calibrated to release lower amounts of nitrogen oxides. Similarly, we see that the modifications that are required in engines are also very minimum. That if an engine is running on CNG, it will run on HCNG also. So it's not that we need a new infrastructure and we need to bring in new types of engines altogether. So we do not have to do that. Engines that work on CNG would, with very minor calibrations, will be able to work on HCNG also. Then after that, it can be used for high load applications and heavy duty vehicles, buses, trucks, etc. So there also we can make the use of HCNG. And that is basically what we also saw, that in Delhi, a pilot project was taken by the government of India where they started running the buses in Delhi on HCNG as a pilot project, just to understand the viability of using HCNG, just to see whether we are in a position right now that we can start using HCNG. So that's why HCNG, for almost like 6 months, there were few buses in Delhi that started running on HCNG to test it out. And now we are analyzing and we are looking at all the aspects of the positives and the negatives that we had out of that project. And depending on that, in the future, we'll look into the viability of running running the public transport on HCNG. So we see that there are all these things and there are better efficiencies and it becomes a better fuel. So higher octane rating also means the same thing, that it's a better fuel to use altogether, gives you a better performance, gives you a better performance. So we see that there are all these advantages that HCNG comes with. But at the same time, there are certain problems, or rather than disadvantages, let me call them as limitations. Limitations. So what are the limitations? First and foremost, we still don't know that what the exact most optimized ratio of hydrogen to natural gas is. Now, it's not that we have not used it in the past, but we still don't know whether that was the best that we could have done. Was that the best ratio? So we need to analyze that more, we need to understand that more. So that is one problem. Then for preparing HCNG, we need new infrastructure. That yes, engines do not need a lot of work, but you have to prepare this HCNG if you want to scale it up. If you want to use it all across the country, you'll need more of it. Correct. So that's another limitation that we get here. Then commercializing it at large scale will take a lot of effort, a lot of investment, a lot of infrastructure setup, calibrations in the engines, HCNG production. There are many things. Before that, even hydrogen production, so that you can use it for HCNG. So there are a lot of things before you can actually commercialize the use of HCNG. And then obviously the current cost of hydrogen is also a problem, because right now the cost of hydrogen, of course, is more than more than CNG. So obviously when you are making HCNG, combining the two, the cost will be higher. The cost of production of HCNG will be higher than the cost of production of CNG. So that also becomes a problem, because if you want to use it for public transport, you cannot ask the public to pay more. The government will have to take the responsibility. So that's also a negative aspect of the economic spending that we'll have to do, or the government will have to do. So from that perspective also, this is not that great right now. The cost of making or manufacturing hydrogen is actually leading to this kind of an issue. So that's why these are all these limitations. Look at this question. This was also asked in your paper. It's an easy question, but read it carefully. Let me launch the poll. Please mark your answers. Hmm. So 29% of you have marked A, 43% B, 7% C, and 21% D. So let me discuss this with you first. In the context of proposals to the use of hydrogen enriched CNG or HCNG as fuel for buses in public transport, consider the following statements. First, the main advantage of the use of HCNG is the elimination of carbon monoxide. Elimination. Remember, we discussed something called as extreme words, right? So elimination can also be bracketed as an extreme. Elimination means what? That completely you are getting rid of carbon monoxide. But what did we discuss here? We discussed that it reduces, right? There's a reduction in the amount of emissions in carbon monoxide. We cannot say that it eliminates carbon monoxide. So that's why elimination is wrong. Elimination is wrong. So A cannot be your answer and D cannot be your answer. You are left with either 2 and 3 only or 4 only. So let us look at 4. Only one statement to see. HCNG makes the fuel less expensive than CNG. It's the opposite, right? We discussed that hydrogen production is costly. So that's why it will increase the cost of CNG. So that's why HCNG is costlier as compared to CNG. So that's why 4 is wrong. So anyway, we are left with only one statement, that is 2 and 3 only. So second statement is HCNG as fuel reduces carbon dioxide and hydrocarbon emissions. Yes, that's correct. And that is why we are looking at hydrogen, because hydrogen is clean. We had discussed this. Hydrogen up to 1/5 by volume can be blended with uh, CNG as fuel for buses. Now, see, this is a difficult statement. I would never be able to mark on the basis of statement number 3 unless I have the exact information from the newspapers. So that's why statement number 3 could have become difficult. But as you see that in this particular scenario, we are not dependent on statement number 3 to answer this question. Yes, if they come to the present format, where they are asking whether only one statement is correct, or two statements are correct, or three statements are correct, or all of the four statements are correct, that is where this becomes an extremely difficult question to answer, right? But with elimination technique, of the past. Now elimination technique also has not been eliminated completely. Yes, this still are, there are questions, but this time the number of those kind of questions were huge. There were, I think, 49 questions, if I'm not wrong, where it was one statement only and two statements only, and so on kind of question pattern. So in that pattern, it would become a very difficult question, because statement number three is very factual and makes it extremely difficult to answer. But with elimination technique that works here, uh, it becomes easier for us to answer this question. All right. So this is it about HCNG. Now, this basically brings us to the end of all the non-renewable sources of energy. Now we come to the renewable sources of energy, and this is where we start with solar energy. So the first energy source is solar energy. Now this solar energy is what? This is an energy source, of course, that we get from the sun. And if we can use it in some form or the other, we can use it for getting energy where however we can. Unfortunately, we do not have developed that technique that this guy had. So we cannot directly use solar energy, but yes, there are multiple ways in which we have found the use of solar energy. Now energy, the solar energy that we are getting, we can get in two forms right here, correct? So either the heat of the sun or we use the light of the sun. Now solar energy is one of the fastest, or other, let's say the fastest growing source of, alternate source of energy. So out of all the different types of energy sources that we have, the alternate sources of energy that we have, solar energy has been growing the fastest, correct? In India and the world, in India and the world, solar energy has been growing the fastest. And we want to get away from our requirements of coal and petroleum right now. For example, for electricity production, for electricity requirement that India has, almost, do you know how much of electricity does coal provide us? What's the percentage in terms of the entire electricity requirement of India? How much is being provided by coal? Yeah, so almost 55%. All right. In, so 50, almost 55% basically is the thermal energy. Thermal energy based on coal. Almost 55%. 5 years back, it was almost 70%. So now we have been able to reduce it to 55%, and we want to reduce it further. This is the goal that government of India has taken, that all the energy requirement that India has, by 2030 we should be using more than 50% of renewable energy and less than 50% of non-renewable energy. All right. So that is why electricity right now, the thermal electricity or thermal energy that we are getting, it's largely based on coal, and it's more than 55%, in the range of 55 to 60%. So 55 to 60% of energy comes from coal, and we don't want to be dependent on coal right now at all. And that is where energy sources like solar energy become extremely important for us. And that is why we also had kept a certain number of targets. There are certain targets that India had. So when it comes to the renewable energy targets, India's renewable targets, so there are two targets that we have. One is the target that we had kept for 2022. So the 2022 targets were that solar energy should contribute 100 gigawatt, wind energy should contribute 60 gigawatt. So this is 160. Then biofuels should contribute 10 gigawatt, and small hydroelectricity power plants small hydroelectricity power plants should contribute 5 gigawatt. So this was the target. So in total, the target that we had was 175 gigawatt. All right, 175 gigawatt. And then comes the target that we have kept for 2030. So for 2030, we have kept a total target of 500 gigawatt. 500 gigawatt, which would include newer sources as well. This would include solar, this would include wind, this would include biofuels, this would include small hydroelectricity power plants, this would also include hydrogen, and this time they have also kept the name of nuclear energy. So all these combined, we want that we should have achieved 500 gigawatt of total renewable energy. So initially, until now, we have been calling it as renewable energy targets. This time, the name, or you can see in a manner, the nomenclature that is being used is non-coal, non-petroleum sources. Non-coal, non-petroleum sources. Right, non-coal, non-petroleum sources. So so that's why calling them as renewable exactly would not be correct, because there are other things as well. So for example, even they also have been started talking about the large hydroelectricity power plants as well. So when you are talking about large hydro, then in that case, large hydro should not be counted as a renewable source of energy, because it is a big source of methane. It becomes a big source of methane. All the big dams that we construct, that becomes a big source of methane, and that's why we don't want to call it as renewable. So that's why we often use the term non-coal, non-petroleum for these kind of targets. Now the targets for 2022 were these, out of which there are certain targets which we were able to meet, and there are certain which we could not. So for example, out of the 100 gigawatt target of solar energy, we were able to reach around 63 gigawatt. We were able to reach around 63 gigawatt. Out of the wind energy target of 60 gigawatt, we were able to reach almost 42.5 gigawatt. In the scenario of biofuels, we were able to cross the target, and we could reach up to 10.7 gigawatt. And in case of small hydroelectricity power plants, we were almost there. We were at 4.9 gigawatt. So in this manner, these were the targets, and this is what we achieved. So in certain cases, you can see that we almost reached up to 65-66% of the targets that we had, and there are couple of cases where we were able to almost reach the targets, or go beyond the target. So a total of 175 gigawatt was the target that we had for 2022. Now this continues further, obviously, that today we see that this solar energy has gone beyond 67 gigawatt. Wind energy also we have been able to increase. Biofuel we have been able to increase, and there are others also where we are trying to contribute more. We are trying to get more out of all the other sources of energy also. Already we have a plan for green hydrogen, right? There's a plan for green hydrogen. So there is the national green hydrogen mission, correct? We have the national green hydrogen mission. So national green hydrogen mission will try to increase the production of green hydrogen in India? We have the National Green Hydrogen Mission, and National Green Hydrogen Mission, we want that it should have a target of 125 gigawatt by 2030. So that's why we want hydrogen also to become a part of the mix. We this time also want nuclear energy to become a part of this mix, and all these were not the targets that we conventionally had in mind, but there are all these different sources also that also are now being brought into the picture. And that's why now we are saying that we are talking about non-coal, non-petroleum sources, instead of saying that we are calling it as renewable sources. So just understand the difference, because you'll see that there are all these kind of terms that will be used by the government, that instead of saying renewable, they'll say non-coal, non-petroleum. So when they say non-coal, non-petroleum, they can bring in others as well, which cannot be conventionally called as renewable. So this is basically how we look at all these different aspects of energy. Now when it comes to solar energy, there are two ways in which this energy can be used, either as solar thermal or as solar photovoltaic. Now thermal, already I told you that the term therm, wherever you see, it means that we are talking about heat, correct? So that's why whenever we are making the use of sun's heat, we'll say that it is solar thermal. And whenever we are making the use of the radiations of the sun or the light coming from the sun, then in that case we say that it is solar photovoltaic. So photovoltaic, now just understand this term as well, that when we say photo basically corresponds to light. Light particles are also called as photons. So that's a photo. When you say that I'm taking a photo, what basically are you doing? You are capturing the visible light through your camera or something. So that's why it is called as a photo, because that's light. Voltaic is what? Related to electricity, right? Voltaic is related to electricity. So that's why when we are getting electricity from the light of the sun, when we are generating electricity from the light that we are getting from the sun, or radiations that we are getting from the sun, then in that case it is called as solar photovoltaic, right? So that is how we are getting this particular term. Now, in case of solar, so that's why solar energy, there are two ways in which solar energy is being used. Now, when it comes to solar heat is not a very popular source because you do not generally get energy from there. But there are some plants in other parts of the world where even solar thermal is also used for electricity production. For example, the biggest such plant was constructed in Israel, where they have large body of water, where concentrated amount of heat is heating that body of water, and then from there on the heat of the water will make the water evaporate, and water will convert into steam, and that steam will be used for generation of electricity. So the solar thermal is something that they use for electricity production. But in India, that's not a technology that we have been using. In India, we use solar panels. We directly use solar photovoltaic. So in case of solar photovoltaic, what we right now see is that we make the use of something called as solar panels. All right, we make the use of solar panels. Now, in case of solar panels basically are devices that are used to convert solar energy into electricity. Solar panels, they will convert solar energy into electricity, and they will basically be made of smaller solar cells, and these solar cells together will make up the solar panel, and these solar cells are made of something called as semiconductors. They're made of semiconductors. Now, when we say semiconductor, the meaning of semiconductor is that it is not completely a conductor, it's not completely an insulator, but it might act as a conductor under certain circumstances. So then in that case, we say that it's a semiconductor. All right. So semiconductors basically they become conductors under certain circumstances or certain conditions. So this is basically how we define a semiconductor. All right. Now, in case of a semiconductor based solar panel, this is basically how solar panel works, that you have the sunlight photons or the particles that are coming from the sun, they would hit or they would strike the solar cell. Now as they strike the solar cell, this is where the flow of charge would start inside the conductor. Now just understand what's happening here. So you would have, let's say, the conductor like this, sorry, the semiconductor like this. So you have the semiconductor, and inside this semiconductor, there are all these charged particles, or let's say electrons for simplicity. Let's say all these electrons basically are haphazardly arranged inside the semiconductor. Now what happens? The solar photons they strike. Solar photons strike. Now, as soon as the solar photons strike, what next happens is what happens is that you have this semiconductor now, and this semiconductor now will have the charged particles or the electrons arranged in a certain direction, in one single direction. So as soon as they are arranged in this direction, this is where the flow of charge through these electrons will start. So as the flow of charge starts, this is how electricity is produced. So for electricity production, basically we need the flow of charge, and that flow of charge is facilitated by the sunlight. All right. So I'm just writing it here. When sunlight sorry when sunlight strikes a semiconductor, the electrons inside the semiconductor are arranged in a direction leading to the flow of charge, thus generating electricity. All right. So basically, this is basically what happens inside a solar cell. So this is a solar cell. This is a solar cell, and inside the solar cell, this is what happens. So this is a semiconductor. So semiconductor is any material that is neither a complete conductor nor a complete insulator by its nature, but under certain circumstances, it can start behaving like a semiconductor. Sorry, it will start behaving like a conductor. So that's why it is called as a semiconductor. All right. So that is how the solar panels would work. And these solar panels, they basically produce, because the electricity flow or the charge flow is happening in one single direction. That's why this is a kind of current which is actually called as direct current. It is called as direct current or DC, and this DC has to be converted into AC or alternating current if you want to provide electricity to the houses. So for that we use an instrument which is called as an inverter. We use something called as an inverter, and with the help of an inverter we see that the direct current can be converted into alternating current. Now direct current is the kind of current or is the kind of electricity that we can store. All right, it's the kind of electricity that we can store. So for example, let's say any electrical device, any electronic devices, a device that uses a battery. So inside the battery you have stored energy or stored electricity that you can use whenever you want. So that is direct current. The stored electricity or the stored energy is the direct current. But that's not something that our houses use for providing electricity. For that, there's another form of electricity called as alternating current. So alternating current mainly because it alternates its direction. It keeps on reversing its direction every second or multiple times in a given second. So it's called as an alternating current. So the power supply that we get at in our houses, that is basically alternating current, and that's why we use an instrument called as an inverter. The role of the inverter would be to convert direct current into alternating current. And that's why, I mean, maybe some of you also have inverters in your home, and if you have inverters you'll see that inverter will always keep getting charged. You keep it charged so that it has enough of battery power or storage stored energy available as soon as, let's say, electricity supply is cut off. Whenever electricity supply is cut off, what happens? You'll see that this inverter basically has been storing energy all this while, and now this energy starts to pass through this inverter, and basically the direct current, the stored current, converts into the current or the electricity that we need in our homes. So this is basically how the working of solar panels happen. This is how solar panels basically work. Now, apart from solar panels, one more device that has been very important in India has been solar pumps. In the last 3-4 years, we have seen that there has been a lot of emphasis that has been given to solar pumps, and especially the use of solar pumps in agriculture. Now, when it comes to solar pumps basically is something that we are trying to replace, or we want to replace the diesel pumps and other pumps with solar pumps. And then again, there are schemes also that have been run so that all these things can be achieved. So solar pump, first and foremost, obviously it is the pump which will provide water, maybe for irrigation purposes, largely in agriculture. And these pumps will be connected to, again, solar panels. They'll be connected to solar panels, and they'll provide you energy with the help of the solar panels. So instead of using diesel, we'll be able to use solar energy for the production of electricity. Now, solar pumps either can be DC or AC based, depending on what kind of technology, what kind of electricity we want, whether we want to provide stored energy or whether we want to directly connect it to electricity supply. So depending on that, it can be either a DC or an AC solar pump. Now, most importantly, what we see is that there are two types of pumps. One which is called as the submersible pump, and the second one which is called as the surface pump. Submersible pump and surface pump. Now, in case of submersible pump, this is the pump. This is the kind of pump where the pump is situated underwater. The pump is situated underwater. That's called as submersible pump. And in case of surface pump, the pump will be kept near the body of water. It will be kept near the body of water, not inside the body of water. So generally speaking, what we see is that if you have a stagnant source of water, then in that case submersible pumps work well. But if you have a flowing source of water, then in that case surface pump suits better. So for example, if you have a well, right, if you have a well or a lake, a dam, then all those cases submersible pump will work very good. But then if you have a river, you have a canal, in all these cases surface pumps actually will become good. So that's why we see that these are two technologies in surface in solar pumps that are often used. Now in so that's why surface pumps and submersible pumps. Now in this particular scenario, when we look at the surface and the submersible pumps, one more way in which technology is used in these pumps is centrifugal and positive displacement pumps. Now, centrifugal pump is the kind of pump that uses centrifugal force. So, what is centrifugal force? If you remember from the last chapter, we discussed that when you have a circular motion, the force that is exerted outward, the force exerted outward in a circular motion is called as centrifugal force. And when we are using centrifugal force in any pump, it is called as centrifugal pump. So what is basically happening, that there is a motor that you have inside the body of water, and this motor will rotate, and as the motor rotates it will keep on throwing water outward. Correct. As the motor rotates, it will keep on throwing water outward. So then in that case it is called as a centrifugal pump. The second one is a positive displacement pump. Now, in case of a positive displacement pump, basically this is a kind of pump which works very similar to how an injection works. If you've seen an injection, you'll see that if let's say they are drawing something from the bottle of vaccine, you'll see that they will just pull the piston of this injection. So what happens is that as they pull this, there is a pressure difference that is created inside the injection, and because of this pressure difference, we'll see that there will be a capillary rise there. The liquid basically will rise inside this injection. Something similar is used in positive displacement pumps as well. That in positive displacement pumps also you will have this kind of a piston, and as the piston goes up, we'll see that water level will also rise in the pump. So that is called as positive displacement pump. So that's your centrifugal pump and the positive displacement pumps. These are the two types of technologies that are used in solar pumps. So that's a centrifugal pump and the positive displacement pumps. Now, in all these scenarios, what we have seen basically is that there is a scheme called as the PM Kusum scheme. PM Kusum scheme. Now, under the PM Kusum scheme, the basic objective is to replace the uh, diesel pumps with solar pumps, and also solarization of newer areas, solarization of newer agricultural fields. That wherever you did not have any pump, any irrigational facility, or wherever you did not have any pumping mechanism or even diesel pumps working, in all these cases, these newer areas have to be tapped, and there also uh, these pumps be provided. And at the same time, wherever diesel pumps are already in use, they want to replace the diesel pumps with the solar pumps. And replacing the diesel pumps with solar pumps has its own advantage. What's the advantage? The advantage would be that first and foremost, you're not using diesel. So you have the environmental advantage because you're not using diesel. At the same time, the agricultural diesel is subsidized. Agricultural diesel is subsidized. So government loses money. Government is giving it at a rate that is subsidized. So that's why they are going to lose money there in subsidies. At the same time, even for the farmers, even though they are getting the subsidies, they still have to keep spending that money. Correct. They have to keep spending that money so that they can get the irrigational facility. So all these are certain limitations of diesel pumps and other technologies right now. So that is where we see that solar pumps will have a positive impact. So that basically is how we are looking at the PM Kusum scheme. The objective is first replacement of diesel pumps, secondly solarization of new areas. All right. So first is solarization of new areas, and secondly replacement of diesel pumps with solar pumps. All right. So in this manner, we see that PM Kusum scheme has been working, and even the pumps that are being provided, the solar pumps that are being provided to the farmers, they are being provided at a highly subsidized rate, almost 75% subsidy. They're giving almost 75% subsidy. They're giving 75% subsidy on solar pump prices. Right, they're giving 75% subsidy on solar pump prices. So now in this scenario, what then happens is that they'll be able to make it affordable for the farmers. And this 75% subsidy means that if, let's say, the cost of a solar pump is rupees 100, then the farmer only has to pay rupees 25, and rest 75 rupees will be shared by the center and the state. The 75% value will be shared by the central government and the state government. So in this scenario, they'll be able to provide this 75% subsidy, so that it makes it easier for that solarization to happen. So ultimately, there is something called as the National Solar Mission. Now, as a part of the National Solar Mission, the target that was kept, as I told you, was of 100 gigawatt by 2022. This was the target that was kept as a part of the National Solar Mission. Initially, although the target was only 20 gigawatt, but then the target was revised, you can say, on the sidelines of the Paris Climate Summit that happened in 2015. That is where the targets were revised. And National Solar Mission basically had a revised target from 20 gigawatt to 100 gigawatt. So in this manner, we see that National Solar Mission ultimately tries to increase the solar installation capacity that we have in India, the total installed capacity that India has. We basically are trying to increase that capacity with the help of National Solar Mission. And that's why there are multitude of schemes that India has launched. And all these schemes together, they are helping in improving our capacity with solar energy. So that's why this National Solar Mission, with all the aims that it has, it becomes very, very crucial from the perspective of India's um solar capacity. So to have long-term policy, to have long-term deployment goals, better research and development, and also getting the domestic production of critical raw material. Now, this is also very, very important, critical raw material components and products, because this is where India also landed in a controversy. Because what happened is that until 2013-14, we did not really have a lot of emphasis. Yes, we had started working on these alternates, but all of a sudden we became very aggressive with all these alternates. So now, when our target was revised to 100 gigawatt, then this target was not that easy to achieve. And the solar panels, especially the production of solar panels did not happen in India a lot. All right, solar panel production in India or manufacturing in India was not happening at a very high rate. So that is where, and largely we were dependent on the imports happening from the US, imports also happening from China and other countries, but largely US. For US, India was a big market for solar panels. Now, all of a sudden, what India said is that now we'll stop importing solar panels from US and other countries, and will start domestic production of, or domestic manufacturing of, solar panels. And solar panel manufacturing was made a part of the Make in India project. So now what happened is that all of a sudden solar panel became Make in India, went to Make in India, and because of that we said tata bye bye to US, saying that we are not going to buy it from you anymore, we are going to produce it on our own. So now, as soon as this happened, this created a lot of controversy, because ultimately what happened back then is that the domestic market of US was highly dependent on India. They're the people who are working in these kind of industries. They were highly dependent on India because India was a big buyer, and that's why all of a sudden uh, they would lose the domestic market. I mean, the employment of the domestic market would be under threat. So that's why India was actually dragged to the WTO, or the World Trade Organization, back then by US, and India also basically uh, put its part. That, see, we are looking at a big uh, revision in our targets, and with that it's not even possible for us to depend completely on imports. So yes, okay, fine, will not overnight will not stop buying it from you, but we'll start phasing it out. That will start producing more in India and import less from the other parts of the world. So that's why it also sparked a controversy back then when India said all these things. Look at this question. This was asked in your 2020 paper. Sorry, 2000, yeah, 2020 paper. Launching the poll for you. It's an easy question. Please mark your answers. Hmm. So 66% of you have given the correct answer. That's great. Let me just explain for the rest of you. With reference to solar water pumps, consider the following statements. First, solar pump can be used for running surface pumps and not for submersible pumps. This is completely wrong. We discussed that there are two types of pumps and we use the both depending on what kind of water source we have. So that's why definitely first statement is wrong. Second statement says solar power can be used for running centrifugal pumps. This is perfectly fine. And not the ones with piston. Not the ones with piston. Now, the ones with pistons are what? Positive displacement pumps. So, saying that all the ones which the piston have, which have pistons, can't be used is also wrong. So that's why correct answer here will be neither one nor two. Correct. So that's why the correct answer will be neither. And this was basically asked because 2019 is when the PM Kusum scheme was actually uh, announced by the government of India, and in 2020 this question actually was asked in your paper. Now, next is solar tree. Now, in case of a solar tree, basically this is a mechanism. If you look at this, this is a mechanism with which we can actually use a vertical structure, right? We can make the use of a vertical structure instead of horizontally laying down the solar panels. One of the biggest problems in trying to increase our solar energy production or increase our solar energy capacity is how and where do you install the solar panels, because solar panels are installed horizontally, right? We install them horizontally, so it takes up a lot of space. It takes up a lot of space, and that becomes a big challenge if you have major solar parks or mega solar parks. In all those cases they would use a lot of land resources. Now that is where we see that uh, this is the solution, where instead of laying them down on the horizontal ground, you have a vertical structure and in this vertical structure now you are installing all the solar panels. So in that case, what happens is that these solar panels will not take as much space as it would originally have taken. And even if it is agricultural field, there also it can be used. Otherwise, right now what happens is that because a lot of it is horizontally laid, and largely you see that agricultural fields are used, so that has a direct competition with agriculture, which is not good. So that's why we see that in all these kind of areas, it will become very crucial. A kind of technology like this will become very crucial. So that's why we see that like a tree trunk will be using it, and that's why it is called as solar uh, tree. And this is a concept in India which is being developed by CSIR, Council for Scientific and Industrial Research. They have been the ones uh, who have started about this, and we see that slowly and steadily there are states which are coming forward, and they actually are installing solar trees. So they basically they can have a lot of uh, uh, advantages. For example, they can reduce the land requirements because instead of horizontal, you have a vertical setup of solar panels. Then very easily wherever you want you can install it. So rural areas, urban areas, everywhere we can make the use of solar trees. Then it helps in addressing the increasing demand for green energy, because this is the way in which solar energy can actually be exponentially made to grow rather than the slower growth that it sees. Obviously environmentally friendly, and can also be used in increasing the farm income. That for the farmers especially, who lets the installations happen, and wherever the installations are done in these kind of farms, a part of benefit can also be given to the farmers, and hence it can be used in increasing the farm income altogether. So overall, when we look at the advantages of solar energy, many of them are self-explanatory for you. It is renewable, environmentally friendly, wide availability because sunlight is everywhere, so we don't need to think about its availability. Versatile because can be used in many forms. Low noise because there is no movement, there is no machinery, so that's why there's no noise factor. Maintenance requirements are low. It can very easily become remote and portable power options. The return on investment is high because ultimately see, the initial investment in solar energy could be little high, but because it can work for a very long time, that's why these are not the issues that we are concerned about. So that's why the return on our investment is very good. Then energy security is increased. Now energy security means what? That when we become self dependent with our energy requirements. That is called as energy security. And we obviously want energy security in one way or the other. Then it is an evolving technology. We see that there are changes, there are increase in the efficiencies that we also see, and it can lead to a lot of employment generation because we are adding capacity. You will need people who can run the operations, you'll need people who are going to be involved in all these kinds of technologies. So that's why we see that there are all these advantages. So for example, there is another scheme by the government of India called as the Surya Mitra scheme. Now, this Surya Mitra scheme is an employment generation scheme in a manner where there is a training of people done so that they become good trained resources in solar energy, and then they will be able to find opportunities in solar energy. So that is what the Surya Mitra scheme has been about. So that's why we see all these advantages. Lastly, the disadvantages, that it is expensive initially, but as I told you that return on investment is good. So that's why when you look at a long term, you'll see that this is good source of energy. It is a daylight only solution, right? You cannot just keep on producing or keep on generating electricity as you want. Only when the sunlight is available. vulnerable to atmospheric conditions, whether it is raining conditions or even cloudy weather in general, or even air pollution. In case of air pollution, the smog kind of situation that often develops in the winter months, there also we see that that can also lead to reduced amount of electricity production through solar energy. So that's why clouds, rain, or even air pollution. So all these can reduce the production. Then large footprint, basically what we discussed about the large land requirements. And then lastly, manufacturing pollution. So manufacturing pollution basically is the kind of pollution that can happen while the manufacturing is done, right? The pollution while manufacturing of solar panels and other key components. So that will lead to manufacturing pollution. One more problem is the waste, that the waste that will be generated. So for example, let's say any normal given solar panel will be functional for 10 to 15 years. So right now we do not see it as a threat because most of our uh, solar panels are newer, right? They are new. 2016, 17, 18 onwards, we saw that a lot more solar energy has been used. But now when they are functional for 10 to 15 years, that is where the disposal of the waste will become a problem. So that's why in a manner it can lead to a situation where the e-waste management can be threatened. So that's another point that we need to understand and add, that how exactly do we recycle or maybe get rid of the waste. So that's why we see that there are all these problems that we have with solar energy. But whatever be the scenario, still you have to understand that there is no better source than solar energy. Easiest of one of the easiest sources to use, and one of the most easily available sources to use. So that's why solar energy, uh, these disadvantages are nothing as compared to the kinds of advantages that the solar energy is able to give. So let's take a break here. The time is 6:48. We'll take a break, and on the other side of the break, when we are back, we'll have a discussion. Start with our discussion on wind energy and the other sources of energy. Meanwhile, any question that you have, anything that you want to ask, please keep sending your questions in the chat, so that when we come back from the break, I'll first take your questions, and then after that, let's start with the discussion of the next topic. All right. So let's be back by 7:05 and we'll take the discussion further. Welcome back, everyone. So, if you have questions, let me know, and then we shall move forward. Why not we install the solar panels in deserts? Their issues will not come like environmental based issues. So, we do it. It's not that in the deserts we are not using the solar panels. We do it, but the problem at the same time also is the capacity that you can get from there, because the heating issues will be a lot more severe in these kind of areas where temperatures are already very high. So that also is something that we have to look upon sometimes, and that can have a bit of a problem. Otherwise, it's not that we do it. How can we store energy generated from solar panels into capacitor? So, basically, when it comes to the capacitor, you know that capacitor uh, will be able to store the energy between its plates, because electricity is produced there. I mean, electric field is produced there, and that is where the any capacitor will be storing the energy. So, the plates of the capacitor that you have, the plates of the capacitor will be able to store that energy. And when you connect this capacitor to any device, then in that case the flow of energy into the device will also start happening. But that's not required for your examination, just because you asked. How to know exactly where there's coal under the ground or petroleum underwater? So no, petroleum is not necessarily present underwater today. We are saying that the formation started underwater. We are not saying that today all the sources are underwater. No, that's not the case. Because for example, in the Middle Eastern countries, the West Asian countries, it's not underwater, it's desert today. We are saying that the formation started underwater, and we do geological studies to surveys basically to find out where exactly it is. I'm not able to understand how satellites orbit twice in a day. So, how many times the satellite will orbit in a given day will depend on how exactly have you prepared it or how far have you placed it. So, depending on where you have placed it, depending on that, it will have its own orbit around any celestial body. So, for example, if it is near the celestial body, it will complete more revolutions in a given day. If you have placed it far away, it will have less revolutions in a given day. So, depending on how many revolutions do we want the orbit to have, depending on that, we do the designing. So, for example, when you want twice a day, when you want the satellite to complete revolutions twice a day, you have to do it in a manner that in 12 hours it should be able to complete one revolution. So that basically is something that we have to do. Correct, we have to do that. So we calculate the distance accordingly, and that distance we have found to be at almost 20,000 kilometers, 20,200 kilometers to be exact. So that basically is something. that we do. So depending on our requirement, we do the designing. Ozone is also a greenhouse gas. Yes, ozone has a very, very important role to play. And that's why we know that the layer of the ozone that we have, it becomes very, very crucial for us, for the survival, you can say, survival of the beings on the earth, but in a very different way. Vent of a solar pump, if you're asking that, Vivek. So vent basically plays a role in a manner, you can say, in the maintenance of any pump or any solar pump for that matter. So now in this particular case, what happens is that whether it is the control of temperature or the control of moisture or even the buildup of pressure that sometimes can happen, we see that in all these cases, the regulation of the temperature and the pressure and even the moisture for that matter is all done by the vent that you have, or even the air circulation, how exactly it needs to happen. There are all these factors that they can do. How much energy can be stored in a capacitor compared with a battery? uh, Depends on I mean, depends on what kind of material is being used for the battery, what kind of battery we are talking about. So it's not a fair comparison that we can do. What is remote and portable power options? Remote means when you are at a far off area, which is completely away from populated areas. That is what we say is remote. And and portable is something that you can transport. So that is called as portable. Please ask the question once. I see that some of you ask the same question 5 times, 6 times. Please don't do that. Because of that, I may miss some of the questions given by somebody else. How is petrol formed? Can you please report? Not petrol, but we basically discussed about petroleum. And petroleum formation simply is that first, uh, all the organic beings, whether animals or plants, they will get submerged under the seabeds or the lake beds. And from there on, we see that they will be subjected to high temperature and pressure. Then their conversion, chemical conversion starts. First, they convert into something called as kerogen. From kerogen, we see that the breakdown of the longer carbon chains happen. That is called as catagenesis. And then ultimately, we see that there is the process of pyrolysis that helps in the final development. I don't understand solar panel, the arranged semiconductor. Basically, in any given solar panel, you have a lot of solar cells. So you can say that there are smaller cells that are arranged, all right, in this manner. There are smaller cells that are arranged, and that makes up a solar panel. Now, each and every solar cell is what I told you about, that you have a semiconductor where you have all the charged particles inside it, like electrons, etc., for example. And once sunlight hits on them, this is where we see that they get arranged in a certain manner. So when they get arranged, basically what happens is, arrangement means that now you have created a kind of a circuit that now a flow can happen. Otherwise, until now, it was broken and flow could not have happened. So now, once this happens, this is how the circuit is set up and the flow of charge can happen and electricity generation can happen, right? So let's move forward. Yeah. So next source of energy for us is wind energy. Now, even when it comes to wind energy, India has been doing very well in wind energy as well. Some of the data, if you pull from the last 5 6 years, you'll find that at times India has been the fastest growing nation with regards to wind energy in the world. For example, 2018 or 2017. So in 2017 also, India became the fastest growing nation with regards to the capacity addition that we have done in wind energy. And in any case, what we see is that with regards to the entire world, we have become the fourth fastest growing nation with wind energy. So that's why wind energy wise also we have been doing a lot, we have done a lot. As I told you that the targets that we had for 2022 were 60 gigawatt, out of which we could reach up to 42.5 gigawatt, which is a very good number. And going forward, next step that we have is growing it up to 150 gigawatt. So 150 gigawatt is the next target, and it's a very steep target. Nonetheless, what we see is that uh, we have been adding all this capacity. We have been trying to add the capacity to wind energy as much as possible. Now, when it comes to wind energy, first and foremost, what do we mean by wind energy? So, the definition of wind, a very simple class 5 6 definition of wind says that moving air is called as wind, right? Moving air is called as wind. But if we go into the detail, what we basically see is that we can say that it is a kind of kinetic energy that is associated with the movement of large masses of air caused by differential heating of the atmosphere by the sun, irregularities on the surface of the earth, and the rotation of the earth. So there are all these geological and geographic factors that lead to the generation of wind, basically the movement of air. Now, if the movement of air, if the wind speed is above a certain level, then it is possible to harness energy out of that wind. And the the speed that we need for a constant supply of energy is up to 15 kilometers per hour. Above, above 15 kilometers per hour. If the wind speeds are above 15 kilometers per hour, then it helps us in harnessing that energy from wind. So that is where wind energy becomes useful for us. Now, when it comes to India, when we are looking at the Indian perspective, obviously we need seamless flow of air. And the seamless flow of air is something that you can't achieve in forest areas, you can't achieve it in urbanized areas. So, one of the best areas would be sea beaches or the coastlines, right? So, coastlines of India is where we see that most of the wind energy production happens. So that's why if you look at the top 5 states in India with regards to wind energy production, you'll see that we have Tamil Nadu, we have Gujarat, Maharashtra, Karnataka, and Rajasthan. So, out of the top 5 states, 4 of these states are coastal states, and the fifth state is Rajasthan, which is a desert state. So, that's why you have large open spaces available in Rajasthan as well, and that's why Rajasthan also makes the cut to the top 5 states when it comes to the wind energy. So, that's why wind energy is a source where coastal states will be able to contribute more as compared to the inland states, because you need a certain movement to happen. So that's why we see that when the speeds are above 15 kilometers per hour, that is where it becomes easier for us to harness that energy, that is wind energy. Now, with regards to wind energy and how it functions, first and foremost, obviously the rotation of the wind fans will happen, correct? Windmill fans will rotate, and with this rotation, in a manner, kinetic energy is produced. We know that energy that is produced due to movement is called as kinetic energy. So that kinetic energy of the air, the movement of the air, will lead to the movement of the fans, and that is ultimately something that we convert into electricity. So in a manner, basically what we can say is that there is a conversion from kinetic energy. This is a conversion from kinetic energy to electricity, right? Kinetic energy to electricity. So this is how the conversion of energy takes place. Now, in this particular scenario, that is basically how we see that this happens. Now, in case of wind energy, there is something that has been growing now, and this is called as offshore wind energy. Now, in case of offshore energy, this is an energy source or wind energy source that instead of installing on the coast or in inland areas, now we are going into the body of water, in the continental shelves, on the body of water. That is where these installations are now being done. So now in this particular scenario, what we basically see is that this is an energy source that has been growing, although not growing as fast as the inland or the onshore wind energy is growing, but we see that offshore wind energy is also growing. So for example, last year's uh, end of year report that was published, according to that, the total capacity of the world right now is 63.2 gigawatt. Now just imagine that when it comes to onshore wind, India itself has achieved up to 45 gigawatt as of now, and uh, in offshore wind, the entire world combined has been able to generate up to 63.5 gigawatt. Now 63.2 gigawatt. Now because getting used to offshore wind energy is not that easy. Installing the plants is not that easy. Also needs a lot of investment and a lot of research, because you cannot simply go anywhere and you cannot simply install these plants. You'll have to look for the longevity of the areas as well, right? You'll have to look for the longevity of the areas, because not every area is good enough. Not every area is good enough. For example, you have to see the wind speeds, you'll have to see the wind directions, you'll have to see whether these areas are prone to natural calamities. So for example, something like an earthquake or something like um, uh, a cyclone, etc., should not hit these kind of areas. And not only, let's say, this year or next year, but you'll have to ensure for the probably next 10 years or 15 years, so that you can have a long term power plant placed at any given area. So that's why it needs a lot of study, it needs a lot of research before we can actually implement the offshore wind power. So that's why right now we have been trying, but it's not that we have been moving very fast. So for example, India also has been trying, and we basically, there are certain zones that we have picked, mainly in two states, Gujarat and Tamil Nadu. These are the two areas that have been chosen, and these are the areas from where we are going to begin. And not only that, we are beginning now, there is a pilot project that we have started, and at the same time we are also taking help from some of the other countries, because when it comes to the growth of the offshore wind energy, we have seen that the European countries have done very well, especially the North European countries. They have done very well. uh, they have been able to add a lot of capacity, and apart from that, China has been doing very well. And China of late has been very aggressive in setting up of offshore wind. And they not only have been using their own coastal areas, but also all the controversial waters that you might have heard of, for example, the South China Sea. So in all those areas which are controversial, where waters are also being claimed by other countries, you know that China doesn't care. Unfortunately for us also, we have been facing that a lot. But in those shores, on in those waters, they simply have been just setting up their infrastructure even for offshore wind power. And that's why China has been growing very fast with regards to offshore wind. Right now the European countries, they lead, but I'm very sure that very soon China will start leading when it comes to the offshore wind energy. We have been taking help, as I told you, from some of the European countries which have been very good with regards to offshore wind, who have some, in a manner you can say, they have some experience with offshore wind. So that's why these countries will be of good help. So for example, countries like Denmark and Norway, they can be very, very good, because they already have good capacity and good experience with offshore wind energy. And that's why they can be countries which can get us also the help, so that we can also get it going. So that's why uh, we already see that all these are the things that India has been working on, and we have been contacting the governments of other countries as well. For example, with Denmark, we have signed an MOU, so that uh, Denmark will help India build offshore. All right. So offshore wind energy. Let me just write it clearly. Offshore wind energy. Right. So in this manner, we see that we have been actually working on all these projects as well, but harnessing offshore energy is not going to be very easy. So first and foremost, as I told you, that a lot of data collection is required, because we need to understand whether the area is suitable, whatever area we are choosing, whether the area is suitable. So study the suitability of an area. Right, to study the suitability of an area with regards to the long term setup. All right, with regards to the long term setup. So for example, any natural calamity, natural calamity possibilities, natural calamity possibilities, for example, whether cyclone or earthquake or tsunamis etc could hit those kind of areas. And then with regards to the wind direction and speeds. Right, so we'll have to check all these things. So for example, let's say when you look at the eastern coast of India, especially the coast of Odisha, we know that it has been one of those areas which is very highly prone to cyclones. So that's why those kind of areas will be avoided, so that otherwise we might set up and it might get destroyed in these kind of situations. So that's why that's there. And then a lot of investment is required in the setting up process as well. So that's also one of the problems. Then what we see is that in Europe, as I told you, that Europe has been leading in offshore wind production, but there were a lot of incentives for even the private sector to work there. Now, in India, right now, there is no such structure. Whatever is being done by the government itself, and there's no private company involved. So, if private companies have to be involved, you'll first and foremost have to provide them some kind of incentive to work upon this, because it's not going to be very easy, and it is going to take a lot of investment from the side of those companies as well. Correct? They also will have to work very hard in getting that money to in make that investment so that they can build offshore. So smaller startups etc, they'll not be able to help in these kind of situations. Only the bigger companies will be able to, which have that kind of cash, which have that kind of money, which they are ready to lose, or even if they lose, it's not going to impact their business. So that's why we see that there are all these kind of issues. Then right now what we see is that solar energy currently in India is cheap. Solar energy is not that costly in India, and even it is growing right now. Even wind energy, the onshore wind energy is growing right now. It has not been to its pinnacle yet. Correct. So that also is one of the challenges, that because of all these reasons, it's not uh, right now advisable that we leave everything and we start working on offshore wind energy. So that is also one of the reasons why offshore wind energy has been on a backseat. It's not that we have neglected it, but we also know that there is a lot of scope to still grow in solar energy and onshore wind energy, and only then probably we can start moving towards working on offshore wind energy also. Right, so that is where we are. So overall, when it comes to the advantages of wind energy, it is also a renewable source, environmentally friendly source, reduces fossil fuel consumption. Wind energy is also freely available. It has a small footprint, unlike what we discussed in solar energy, because it is a vertical setup anyway. Can be used for both industrial and domestic installations. It can also become a remote power solution. Maintenance requirements here also is less. This also helps us in increasing our energy security and also helps in employment generation. So everything that we discussed with solar energy, almost similar points with regards to wind energy also. So I don't think a lot of explaining is required there. But when it comes to disadvantages, first, the fluctuations. Fluctuations are a big problem, right? Fluctuations, because we need a certain energy speed, I mean wind speed, only then the harnessing is possible. So that is one of the issues that we have. Apart from that, it can also become expensive initially, just like what we discussed in solar energy also, that it can become expensive. But again, because the maintenance requirements are low, it functions for a very long time, so overall return on investment is very good. But initially it is expensive. Then it can also pose as a threat to wildlife, and this is something where we need to understand this very point very well. Now what can happen is that wherever you are setting up a wind farm, obviously the fans of the windmills will keep on moving. For the birds which are living in the nearby areas, this can become a menace, because they would also understand that they might possibly hit the wind fans and they can lose their lives in it. So they would also understand that, and they'll start avoiding those kind of areas. They might perhaps also start looking for a new habitat altogether, because now they also know that their movement in this area is not that easy. So then they look for shifting of the habitats. They might look for shifting of the habitats. Now shifting of the habitats is not going to be easy, because let's say a bird wants to move from this area to another area, meaning from this ecosystem to another ecosystem. In that ecosystem also something similar to this bird already is present, correct? There is a food web that is functional everywhere in any given ecosystem. So that's why even if they try to move to a new ecosystem, it's not going to be, or a new habitat in a similar ecosystem, it's not going to be easy for them to settle down there, because there would be somebody else already there. And then after that there is a competition, and in ecology competition is never good. Competition only means negative for both the organisms or both the species. So that's why we don't want that competition there. All right, right, we don't want that competition. So that's why this is one of the issues, that it basically threatens bird habitats, right? It threatens bird habitats. So that is one of the issues that we have. Apart from that, another issue is that there is no environment impact assessment. There's no environmental impact assessment that is done with wind energy. Now, do you know what is environmental impact assessment? In if I'm not sure whether your environment and ecology classes have happened. Environment ecology classes for you have happened. Okay, hasn't happened for most of you. No issues. So just know this, that when it comes to environmental impact assessment, this is something that is done to understand the viability of any project, to understand whether any new project that somebody is starting, whether it is environmentally viable and socially viable, mostly environmentally viable or not. So for example, you cannot just cut down a forest and set up an industry anywhere. Before, if at all that happens, before that there will be an assessment study that will be done, which is called as environmental impact assessment. All right, it is called as environmental impact assessment. So environmental impact assessment is done for any such project, any large project which can have an environmental impact. Now what happens is that in India there are environmental impact assessment rules. According to these rules, renewable energy sources are exempted. So if let's say solar energy plant is being set up, you don't need any environmental impact assessment. Wind energy, you don't need any environmental impact assessment. So why? Because these are renewable, so they are supposedly good sources, better sources, clean sources. So why to have that assessment? But you have to understand that many a times they have other problems. Other problems. For example, this. Do you know which bird this is? This bird that you have in the pictures here. Yeah, Great Indian Bustard. This is the Great Indian Bustard. Now, what has happened is that this great Indian bustard, there has been a case where this great Indian bustard was electrocuted, and electrocuted by a high power transmission line running through a wind energy farm. So on the one hand, we know that it's a good source of energy. Wind energy is a clean source of energy, but those transmission lines can be a problem. There have been instances in Karnataka, in Gujarat, in Rajasthan, in all these states where some birds have lost their lives because they got electrocuted by the high power transmission lines running through the forests. And these all are, many of them are wind energy farms. So that is where we have to also understand that there is an indirect impact that even wind energy can have. Because great Indian bustard, you might know that great Indian bustard is critically endangered. There are only a few species. I mean, they are just left in very few numbers. They were they were also found. I mean, at one time they were also found in parts of Pakistan, also parts of Nepal, apart from India, of course. But now in Pakistan they are completely gone. In Nepal they are completely gone. Only in India they're left, and in India also only a couple of states, in Rajasthan, in Gujarat, parts of Maharashtra. That's it. So only these three states. So they are left in very small number. Do you know what the number is? Do you know how many great Indian bustards are left? Yes, within 200 is correct. Almost 150 is the number, I think, right now. So less than 150, the number has dropped to less than 150, somewhere around 120 if I'm not wrong. So just go and just search it. So great Indian bustard, just imagine that the entire species has just over almost 120 in number left. So that is where the problem lies. That is where the problem lies, that out of 120 also, if one bird dies, just imagine what kind of scenario this is. So you will simply lose these birds if something like this happens. So that's why this is very very important, that because wind energy, there will be no environmental impact assessment because it's a clean source of energy, but that also can have an indirect negative impact. So that's a threat to wildlife. Then it can lead to noise pollution because of the movement of the fans all the time. For the people who are living nearby, it can be a menace. And then visual pollution, because many of these will be set up in natural areas or maybe in the forest or somewhere. Then in that case, what happens is that this is called as visual pollution. So visual pollution is when you basically have an artificial setup in natural environment. So for example, let's say uh, you decide that you want to build a house in the middle of a forest. So middle of the forest, you will build the house and you will be very happy that you're living in the forest. But at the same time, it's visual pollution, because the natural beauty of that place has been destroyed by you. So that's why it will be counted as visual pollution. So that also, uh, that's why you have to understand that all there are certain limitations or disadvantages also that they come with. Now, coming to our next source of energy, that is geothermal energy. Now, understand what is geothermal energy. You have two words here, geo and thermal. If you break it down, right, you have two words. Geo is what? Something related to the earth, correct? That's why you study geology, geography, etc., where you are studying about the earth. And thermal, we discussed that it is related to heat, right? So that's why when we are talking about the energy that is coming from inside the earth, energy that is coming from the heat that is trapped inside the earth, that basically is called as the geothermal energy. So in a manner, the heat from inside the earth is the geothermal energy. Now in what form? In what form do you have geothermal energy? Now if you see, and I'm sure you know about this, that as you go down below the earth, the temperature also keeps on rising. that if we are at almost 6,000 kilometers below the earth, when you are going towards the core of the earth, the temperature can be as high as 5,000 degrees Celsius. Now there are cases, there are chances that this heat basically is able to vent out towards the surface. So if this heat comes towards the surface, this is the heat that we can tap. This is the heat that we can tap, and we can use this energy. All right, we can use this energy. We can use this uh, uh, energy or heat, and that becomes geothermal energy. So one is from the heat, when coming from the heat that is there inside the earth, trapped inside the earth since the time of the birth of the earth itself, formation of the earth itself. And second, the decay of radioactive elements can also lead to the formation of, or let's say, generation of geothermal energy. Now, radioactive elements, what are they? How exactly they heat up, etc. We'll discuss later. Maybe in the next class when we go to nuclear energy, that is where we perhaps can discuss that. So that's what, just remember for now that there are two sources. One, the heat that is there inside the earth since the time of the birth of the earth, and then secondly, the radioactive decay of the radioactive elements. So in these two scenarios, we see that this is where we have it. All right, this is where we get the geothermal energy from. So that's why there are multiple different types of reservoirs that from where we can get this energy. So hot springs or volcanoes or even geysers, etc., they all can become sources of geothermal energy reservoirs or geothermal energy. Now, when we look at these geothermal energy plants, we see that there are different ways in which geothermal energy is being used. So there are three different types of geothermal energy plants: dry steam power plant, flash steam power plant, and binary cycle plants. So these are the three ways in which we can get the geothermal energy. Now, first and foremost, we have something called as the dry steam plant. Now, just understand the basic principle of how they work. So, in case of dry steam plant, what happens is simply the heat from inside the earth will come to the surface, go to the turbine, leads to the movement of the turbine, and with the movement of the turbine, you get electricity from here. And then from there on, it will go back, and then again from here on, there is a cycle that repeats. So that is how we basically get the dry steam power plant working. So they would pipe hot steam from underground reservoirs directly into the turbines from geothermal reservoirs, which power the generators to provide electricity. So this is basically how a dry steam power plant will be working. So you keep getting the energy from here, the heat from here, you take it to the turbine, and again you send it back, and in this manner, in a cyclic nature, this will keep working. Then we have something called as the flash steam power plant. Now, in case of a flash steam power plant, the design of this power plant is a little more complex. There is one layer of complexity that is added, and that layer of complexity basically is the fact that there is something called as the flash tank. This right here, this is called as the flash tank. All right, this is called as the flash tank. Now, in this particular scenario, in the flash tank, what we basically see is that the heat that is coming from inside the earth, the heat that is coming from inside the earth, what we see is that this basically is maintained at high pressure. All right, it is maintained at high pressure. Now, at high pressure, just understand what happens. At high pressure, water can retain more heat. Water can retain more heat without converting into steam. Generally, what happens? Let's say, generally at normal pressure, at 100 degrees Celsius, water will convert into steam, right? At 100 degrees Celsius, water will convert into steam at normal pressure. But when you have high pressure, the absorption capacity of water increases. So heat absorption capacity of water increases. So even if, let's say, you are at 150 degrees Celsius, even then you can have liquid water. even then you can have liquid water. So normal pressure, that wouldn't happen. Normal pressure 100 degrees Celsius, you have steam, right? Normal pressure 100 degrees Celsius, steam. But high pressure, you, even if you are at high temperature, the water will still not convert into its steam form. It will still remain in its water form, and that is precisely that is used in this particular scenario of the flash steam power plant. So ultimately we see that what they basically do is that in this particular scenario they have the flash tank, where this water, until now you have been maintaining water at high pressure, so liquid water comes to this flash tank. All right, liquid water comes to the flash tank. Now this flash tank is at normal pressure. Flash tank is at normal pressure. Until now, beneath it, you were maintaining high pressure. So as soon as it comes from high pressure to normal pressure, the water will quickly convert into steam, right? Because until now high pressure, that's why it was in liquid form. Now you have normal pressure, so it will quickly convert into steam. So as soon as it converts into steam, basically this steam again you will be using it to rotate the turbines, and electricity generation will happen in a similar manner. So in this manner, there is one extra layer of complexity that has been added, that the source is being maintained at high pressure and flash tank at lower pressure. All right. So that basically is something that we see here. So flash steam plants pump hot water at high pressure from below the earth into a flash tank on the surface, and the flash tank, it has much lower pressure. It is at a much lower pressure, and that is why we'll see that it will quickly flash into steam. So pressure and temperature, rather, I mean, both actually are low. So let me say this: pressure and temperature. All right, pressure, lower pressure and temperature. So that is the basic reason why it would quickly flash into steam. That's why it is said to be the flash steam power plant. Then after that, there is something called as binary cycle plants. Now, in case of binary cycle plant, the term says binary. Binary means what? Two. So there are two cycles parallelly running here. All right. There are two cycles parallelly running here. So that's why it is called as a binary cycle plant. So what happens in this particular scenario? That there is one cycle, as you can see that there is one cycle above and there is one cycle below, right? So below cycle is the cycle of the heat from inside the earth, the steam that is coming from inside the earth, or maybe liquid hot liquid water that is coming from inside the earth. That is one cycle. The second cycle is often organic liquid. Second cycle is often organic liquid. Just remember what we discussed in fractional distillation, that organic liquids have lower boiling points. So what happens here is that this organic liquid that you have right here has a lower boiling point. So as soon as this heat from inside the earth comes in contact with it, it will very easily convert into steam. With lower energy requirements, it will convert into steam. So that's why binary cycle plants, and obviously they convert into steam, and then again they go to the turbine, rotate the turbine, go to the electricity generation from there on. Now in this particular scenario, binary cycle plants especially become important for a reason. There was an IPCC report published. You know what is IPCC? What is IPCC, anyone? Yeah, Intergovernmental Panel on Climate Change. Correct. So, Intergovernmental Panel on Climate Change. What exactly does it do? It does the scientific study, or rather, basically collects the data of all the scientific study that has been done on climate change and publishes those results from time to time. So, for example, there is something which is very, very crucial that they produce something called as the assessment report. they produce something called as assessment reports from time to time. So these assessment reports, until now there are 6 assessment reports that have been published. The latest one was last year in 2022. So there are 6 assessment reports that comes every 5 years, every 7 years, and so on. So for example, fifth assessment report came in 2014, and then the sixth assessment report came in 2022. So they do exhaustive research on all the data, all the studies that have been done on climate change, and they try to draw a conclusion from there and publish those reports. So they become very, very crucial. Now, there was another study that they had done, and this study was based on all the different types of renewable energy and how polluting those renewable energy can be, or whether they are also contributing to pollution and climate change in one way or the other. In that study, what they found is that binary cycle plants are the cleanest source of renewable energy. Cleanest source of renewable energy. This is what IPCC said. This is what IPCC said. So even compared to solar energy, even compared to wind energy, even compared to biofuels, even compared to other forms of geothermal energy, binary cycle plants, according to that report, is the cleanest source of energy. That is the importance of binary cycle plants. And right now, that's why we see that we are working on binary cycle plants. We also want to build these plants in the future plants that we are trying to build. Dry steam power plants have the least efficiency. All right, they are the least efficient. Compared to them, flash steam power plants are better, and compared to that, binary cycle plants are much better. So that is why they actually were in news a couple of years back. Now, coming to geothermal energy, there are certain areas where we have also been able to map the presence of geothermal energy in India. Total energy potential for India is basically said to be 10 gigawatt. The total geothermal energy potential that India has is of 10 gigawatt, and there are all these areas that have been marked for those 10 gigawatts. So you have areas, the Himalayan areas of, first starting from Ladakh, then Himachal, Uttarakhand, and then after that also Sikkim and Arunachal Pradesh. So there are all these states that have been marked, basically because we know that the tectonic lines run like this, right? The tectonic lines run like this, and that is the reason why these areas are so good with regards to the potential for geothermal energy. But apart from that, there are other areas also. For example, the Sonata region or the Son, Narmada, Tapti region. So that also has been marked. And then apart from that, there are other areas also that have been marked. So we see that there are all these potential areas where there are chances that India has geothermal energy. So ONGC basically is mapping India's 10 gigawatt geothermal energy. This is basically that, something that ONGC is doing, and even this map basically is an ONGC map. This map also is a potential map that was published by ONGC with regards to India's potential in geothermal energy. Right now, we have taken small steps. All right. Right now, we have taken small steps in regards to what we are doing with geothermal energy. We have marked certain areas. For example, this right here, the Puga Valley in Ladakh, this Puga Valley area in Ladakh, it becomes a very crucial area for India. This is where there was an MOU also that was signed between ONGC Energy Center and Ladakh Autonomous Hill Development Council for the first geothermal plant that basically is being developed in the Puga Valley. So Puga Valley is in Ladakh, very beautiful place. I mean, and you'll see that there are hot springs all around Puga Valley. So that is what they want to tap. And by tapping it, they will try that at least the local requirements of energy can be sorted. Because these are very harsh areas, very far off areas, remote areas, away from any thermal electricity source or hydroelectricity source. So getting electricity there for the government of India hasn't been a very easy task. So this is where all the local requirements of those areas, the villages nearby, the townships nearby, that can be solved with the help of these energy sources. So that is how in Puga Valley we are seeing this development. At the same time, the Geological Survey of India has identified that there are almost 340 geothermal hot springs in the country, which can become potential sites for geothermal energy in India. Apart from that, we saw that last year there was another development where Geothermal Core of Texas has signed a letter of intent to invest rupees 820 crores in producing geothermal energy in the state of Uttar Pradesh. So in all these cases, apart from that, there are smaller uh, other programs in other states as well. For example, in Chhattisgarh, in Andhra Pradesh, in all these areas also, we have seen that there are smaller developments happening. For example, there is a company, an Iceland based company, because Iceland, when it comes to Iceland, Iceland has a lot of volcanoes and a lot of hot springs, etc. So one of the leading nations with regards to geothermal energy. So there is an Iceland-based company called as Reykjavik Global, and this Reykjavik Global also has come to India, also has shown its interest in coming to India and setting up a geothermal energy power plant. So we see that there are all these developments that have been happening in geothermal energy also. So overall advantages again pretty similar: renewable and sustainable, environmentally friendly, constant supply. Now this is very crucial, because both in case of solar energy and wind energy, we know the problem. Solar energy, as we discussed, is just a daylight only solution, right? We say that it's a daylight only solution. In wind energy also, you cannot predict the fluctuations of wind, and that also sometimes can lead to decrease in the amount of energy that you can produce. But here we see a constant supply, right? With geothermal energy, we see that there is a constant supply, that the heat will keep coming out of the earth and you can keep tapping that energy. Then it has a smaller footprint, because the setup generally is done underground, so it does not affect the ground above. And also, these are not agricultural areas. I mean, these are not areas which are suitable enough for agriculture, because there will be a lot of emissions, sulfur emissions, etc. will also happen. Heat is very high, so not very easy, not very conducive for agriculture. Then it is also cost effective, because you see it as a long term solution. Then the maintenance requirements here also is pretty low. The noise also here is very low. Then obviously it also enhances our energy security, employment generation, and has obviously a very huge potential. So advantages more or less self explanatory. Disadvantages, the very first disadvantage is geographical limitation, because we know that it's not like solar energy that you can get it from anywhere, or not like wind energy where we know that there are areas from where we can very easily get this energy. First and foremost, here we need to identify the areas, identify the hot springs which are good enough, conducive enough to get energy from. So there are n number of reasons that come in the way of you getting to use geothermal energy. So that's why it needs a lot of investment, right? It needs a lot of investment. Then at the same time, there could be possible environmental impacts, because these are areas from where hydrogen sulfide gas could also be produced. Potentially, I'm just writing it here, potentially hydrogen sulfide gas. Until now we haven't seen it happen yet. Chances are there. Then there are sustainability concerns as well, that whether these are good sources or not, long lasting sources or not. So there are all these issues. And lastly, there are chances of seismic instability in these areas. These are areas which can also be prone to earthquake. You know about India also, for example, these tectonic lines, they are very unstable, correct? Very recently we have seen a couple of earthquakes that happened, and with epicenter in Nepal. So that's the same Himalayan region. We see that kind of instability in states like Uttarakhand and Himachal Pradesh as well, in Sikkim also. So that's why we know that these are not areas which are very stable. So there are chances of seismic instability being induced because of geothermal energy. And there are examples of this happening in the past, not in India, but other parts of the world. There has been one in Switzerland, there has been one in the US. In both the cases, there was a very small earthquake. On the Richter scale, it was perhaps just 3.7, 3.8. So, not huge earthquake. But when they were doing the research or the study about the epicenter and the possible reasons, they found that these were areas where uh, geothermal energy power plants have been set up. And that's something which is leading to these kind of scenarios, that is leading to these kind of situations of instability being produced. So that's why we see that there are all these problems that geothermal energy perhaps could bring with itself. Now, coming to the last source of energy in this particular segment, this is bioenergy. Now, when we say bioenergy, what is the meaning of bioenergy? That this is the energy that is coming from biological sources. That's why bioenergy, right? Energy coming from biological sources should be bioenergy. But then in that case, coal and petroleum are also bioenergy, right? They are also coming from organic sources only. Where's the difference? Where's the difference between this bioenergy, from where we are basically getting the biofuel? What is the difference between this bioenergy and the fossil fuel, which is coal and petroleum? The basic difference is the time. Time is the basic difference. How exactly? Because in this particular scenario, when it comes to bioenergy, bioenergy is produced in a very short span of time. Very short span of time. Maybe a few days, maybe a couple of weeks, maybe a couple of months. That's it. So that's why the time that you are taking here is pretty less as compared to the time that you take millions of years, right? 300 million years. So 300 million years on one hand, 2 weeks on the other hand. So there is no comparison, correct? So that's why this bioenergy, when we are talking about energy of biological origin derived from biomass. So biomass. So biomass basically is nothing but the biological material from where you are getting the energy, wherever you are extracting the energy from, that becomes biomass. Now in this particular scenario, so that's why biomass basically is the biological material derived from living or recently living organisms. All right, so whether it is plants or animals or animal waste, plant waste, all these things which are either living or recently living will be called as biomass. And this biomass becomes our source of energy. This becomes our source of the raw material from where energy will be derived from. Now, when it comes to the feedstock is nothing but the raw material. Feedstock is nothing but the raw material. So there can be multiple kinds of raw material. You can have waste, you can use crops, you can use wood. There are multiple things that can be used. So that's why we see that there are all these kind of scenarios, all these kind of things, materials that can be used as a feedstock or a raw material for biofuel production. All right. So that's why we see that there are all these things. So if you see, we started from bioenergy. We see that there are energy crops. We'll discuss about energy crops as well, that are specifically cultivated to provide bioenergy. So bioenergy, biomass, feedstock, energy crops, biofuels, there are 5 terms. Just let me explain. You have bioenergy, right? You have bioenergy. So what is bioenergy? Energy from biological source, right? Energy from biological source. So this becomes bioenergy. And then there we are saying that there are specific kinds of crops. There are specific types of crops which are cultivated for this kind of energy production. So energy crops, they are called as energy crops, right? So energy crops basically are the crops that provide energy. So what is the source of energy for us? What kind of nutrient is the source of energy for us? What kind of nutrient? Carbohydrates, right? So that's why these energy crops are the sources of carbohydrates. Because if they are sources of carbohydrates, it means that they are sources of energy, and if they are sources of energy, they can be used for biofuel production. So energy crops. And then after that, we discussed that you have something called as biomass. So biomass is nothing but the biological material, correct? Biomass is the biological material from living or recently living organisms, correct? So you have biomass, and then after that we discuss that you have something called as the feedstock. So what is feedstock? Feedstock is nothing but the raw material, whatever raw material or whatever biomass you, sorry, or whatever biomass you are using for biofuel production. So feedstock is what? Feedstock is nothing but the biomass to be used as raw material for biofuels, right? And then lastly we have the term that is biofuel. So what do we mean by biofuel? Any hydrocarbon fuel that is produced from organic matter in a short span of time or a short period of time will be called as biofuel. So that is the basic difference between biofuel and fossil fuel. Fossil fuel is also coming from organic material, organic source, but in millions of years. Whereas in case of biofuels, we see that something similar is happening just in a few days or a few months. So that's the basic thing, and that's why short period of time is very crucial here. Now, in this particular scenario, we see that there are different types of biofuels. We have bioethanol, we have biodiesel, and we have biogas. Now, when it comes to the biofuels, we divide all the different types of biofuels that we have into different generations. And this division that has been done, the classification that has been done on the basis of what is the raw material being used and what is the technology being used. So, based on the raw material and the technology, we see that this kind of a classification we have done. So first we have the first generation biofuel. The first generation biofuel basically is based on food crops. These are food crop based, meaning that the same food crops that we also consume, the same can be used as a source of biofuel production. So for example, we use corn, we use soya bean, we can even use rice if we want, we can use potato if we want, we use the oil seeds of different types of oils, we can use all of them. All right, we can use all of them. We use sugar cane here. So all of these are basically based on food crops. So that's why this is called as first generation, where we are, you can in a manner say that the biofuels are competing with our food. So then in that case it is the first generation biofuel. All right, then after that we have the second generation biofuel. Now second generation biofuel is where we start changing up the things. So second generation biofuel basically, for example, can come from agricultural waste. It can come from agricultural waste, and it can also come from municipal waste. So instead of using something that is in direct competition with our food, now we are using something that we are not bothered about. I mean, we are at least not going to eat. So that's why agricultural waste, municipal waste, and non-edible crops. Non-edible crops. So we are basically trying to get our source from here. Now, we would obviously always prefer the second generation over the first generation. But the problem is getting energy from second generation is not that easy. On paper, this is what we want, but in reality, it's not easy to get energy from here. The technology required is difficult, and that's why second generation is also called as advanced biofuel. Right, second generation is also called as advanced biofuel because the technology that is required here is complex. It's not easy to generate energy from these sources as easy as it has been from the food crop based sources, and that's why these are also called as advanced biofuel. So that basically is our second generation. Coming to the third generation of biofuels, what you basically see is that in third generation there are two possible sources that we can make the use of. Either we can make the use of algae for the generation of biofuels, or if not, then we can also make the use of something which is called as bio CNG. All right, we can also make the use of bio CNG. Now, in this particular scenario, first and foremost, algae. Now, algae is seen as a source of the third generation biofuel. All right, algae is seen as the source of the third generation biofuel, algae based or bio CNG. So these are the sources that we are looking at when it comes to the third generation. Now, when it comes to algae, algae does give us a lot of advantages. All right, algae does give us a lot of advantages because few things, just understand a few things with regards to algae, that how algae could be advantageous. First and foremost, algae grow underwater. Algae grow underwater. So there is no competition for land. There's no competition for land resources because in case of first generation biofuel, because these are this energy is something that we are getting from food crops, it ultimately means that there will be a competition for those agricultural land. That whether do you use that agricultural land for food production or do you use that agricultural land for biofuel production. So there is a competition in the land resources. But because algae is growing underwater, it's fine. Correct. So that is one advantage that algae can give us. Algae based biofuel. Secondly, they grow fast. They grow within a couple of weeks. So that is also one of the major advantages, that growing them does not take us a lot of time. For example, any crop at least will take a month, if not 2 months. Correct. So it will take a month or two at least before we can get energy or harness energy out of it. But in case of algae, the growth of algae is pretty fast, and that's why we'll be able to get energy very quickly. Then apart from that, they have better efficiency. Meaning that, let's say from food crops, if you have 100 grams of, let's say, any food crop, then from there on you produce somewhere around 40 to 45 grams of energy, or equivalent of energy. Whereas in case of algae, we see that this efficiency is better compared to the food crops. So 100 grams of algae will give you more energy as compared to 100 grams of a food crop. So that's another advantage that we have with algae. So growing algae happens underwater, growth happens within a couple of weeks, and efficiency is great. Then we should just leave everything and work on algae, correct? We should use algae as our primary source. Why don't we do that? Because technology again is even more complex than compared to second generation biofuel. Extracting energy from algae is not that easy. It's very difficult. It needs a lot of investment. Experimentally we have been able to succeed. The world has been trying, India has been trying, but we haven't had a great success with algae on a large scale basis. We haven't had a good success on a large scale. So at an industrial scale or at a population scale that will need, we haven't been able to succeed there. Experimentally we have, theoretically we have been able to produce energy from there, and we have seen all these advantages. Yet we need more advancement in technology so that algae as a primary source perhaps someday could be used. So that is where we see the problem right now. Then comes the fourth generation biofuel. Now, fourth generation biofuel is pretty experimental in nature right now, in a very nascent stage, and not even very well defined. Even for example, let's say when you look at the biofuel policy of India, there is no mention of any fourth generation. Similarly, for other countries also, you'll see that there is no fourth generation. So, fourth generation is largely theoretical right now, and something where a lot of research is happening, a lot of studies are happening, so that maybe in the future we can use one of those as a source of biofuel, right? So largely research based in early stages of development. Okay, so this is basically how we have our fourth generation. So largely they are largely research based in early stages of development. So there are multiple ways in which we are trying and looking at the fourth generation. So for example, we might use uh, genetically modified organisms here. We also want to use microorganisms here. So microbes could become a source. Genetically modified organisms can become a source. Second generation source with carbon sequestration can also become a source. This is also something that we are trying. That whatever small pollution happens because of carbon dioxide emission in the first and the second stages, we basically want to get rid of that. That use the same source as the second generation, because anyway that is based largely on wastes. So use the same source, but whatever carbon dioxide is emitted from there, use that carbon dioxide. Just take away that carbon dioxide, store it, capture it. So that basically is called as carbon sequestration, right? That is what carbon sequestration is. What is carbon sequestration? Capturing and storing carbon dioxide, right? So that basically is carbon sequestration. So these are the things that are being tried. So that's why fourth generation is not pretty important for us right now, but this is where we see that we are heading in the coming days, and we would want that we basically can use fourth generation also if we can. But right now we are largely, just remember this, that probably you can say that almost 85 to 90% of all the biofuel even today is first generation. Second generation has just started taking shape in the past few years. Third generation still is experimental. Fourth generation right now is nowhere. So largely we are still in the first generation itself. Not only India, I'm talking about the world. The world right now is largely in the first generation, and we are still trying to move away from first and use more of second generation as much as we can. So still we are actually uh, trying to take care of, I mean, trying to get into the next stages. All right. So largely when it comes to the types of biofuels, there are two major types, biodiesel and bioethanol. So biodiesel is something that we get from vegetable oils, right? We get it from vegetable oils through the process of esterification. So any oil seed can become important here. And then when it comes to bioethanol is something that we get from the fermentation process of all these energy crops. Biodiesel is something that can be mixed with or it can replace diesel. And we'll go into the details of how exactly all these things will happen in India in detail tomorrow. But we know that biodiesel can be mixed with diesel or it can even replace diesel. In case of bioethanol, it can be blended with petrol or it can replace petrol altogether. So we are looking for a blending. So for example, India has a target of 5% blending of biodiesel with diesel and 20% target or target of 20% blending of bioethanol with petrol. So this is basically where we want to head in the coming years. So in case of, because both when it comes to biodiesel and bioethanol, they both are going to be very very important because they have very huge positive impact on pollution. So for example, biodiesel can reduce the exhaust emission by up to 80%, carbon dioxide exhaust emission. There is no sulfur dioxide. Even the particulate matter PM 2.5 and PM 10, even that can be reduced by up to 75%. Then even when it comes to the flash point, even flash point is higher. So that makes basically biodiesel a safer fuel as compared to the normal petroleum diesel. So there are so many things, and even they can provide significant lubricity improvement as well, that it can become easy source for lubrication of the machine parts and engine parts, and hence increase the capacity as well, increase uh, make it better and improve the working of this biodiesel. So that's why there are all these advantages that we have with biodiesel altogether, and overall that's why we want basically to use biodiesel as much as possible. Then there is another source for biodiesel, and that can be jatropha. Now, jatropha basically is this plant, and there are fruits that you have on jatropha. The seeds that you get from these fruits, they can be used as a source of biofuel. So, jatropha basically is also cultivated. Now, with jatropha, what we have seen is a big change initially. Uh, by initially, I mean almost 20 years back, jatropha was seen as the primary source of biofuel in India. Primary source of biofuel in India. But then all of a sudden, we saw that jatropha almost lost whatever value it used to have, because we saw that the conversion rates of jatropha was very poor. So two things happened with jatropha. Although it's not that we are not using it as a source today, but we see that we are not using it as a primary source. We don't look at jatropha as a primary source today. We used to. Two things. One, it takes a lot of time to grow, takes 6 to 7 months for biodiesel production. All right, that's one problem. And second problem is conversion rate is very poor. Almost at around just 20%, meaning that if you have 100 grams of jatropha seeds, from 100 grams of jatropha seeds, you get just 20 grams of jatropha oil, which can be used for biodiesel production. So that's why the conversion rates are very poor. On the one hand, we see that all the crops that you have or algae, etc., can give you up to 40-45% of conversion rate. That is, from 100 grams of that, you get almost 40-45 grams of biodiesel or bioethanol, whereas in case of Jatropha it's just around 20%. So because of these two reasons, we see that initially we were looking at it with a lot of enthusiasm, but ultimately government also lost its interest because they also realized that it's not a viable source when it comes to the commercial production. When we were just experimentally looking at things, then Jatropha looked to be a very good option. But then once we started looking at a big scale production, this is where we see that Jatropha was not really seen as a very big source. So that also became one of the reasons why we see that although Jatropha was seen as a good crop, that we know that it can be cultivated anywhere along the canals, roads, railway tracks, border of farms, etc. Even in alkaline soil, you can just cultivate it. It grows very easily. Even in scarcity of water, it can actually grow. So that's why with all these things, it looked like it will be a very good prospect. But when we looked at the conversion rate, this is where we found that it probably will not be as good a prospect as we initially thought. So that is what happened with Jatropha. So let's end here. Let's start discussion from bioethanol onwards in the next class tomorrow. If you have any doubts, if you want to ask anything, you can ask now. Otherwise, we'll have a discussion tomorrow. Why why does Andhra Pradesh not have wind power installations as it has long coastline? See, the problem is not with Andhra Pradesh, but the problem is with the eastern coast. That eastern coast is not viable enough because very frequently a lot of cyclones strike the eastern coast of India. So that is the reason why we don't want a lot of installations on the eastern coast. Space policy is not uploaded. I think it has been uploaded because it was supposed to be at the back or towards the end of uh, the the PPTs or the PDF that you have from the previous class. Just please check that once. How fans run in dry steam power plant? There are no fans, but there are turbines, and turbines can basically run. How much does the temperature increase as we move 1 kilometer inside the earth? See, variation is not constant. All right, variation is not constant. For the first 100 kilometers, the variation is gradual, and then the variation in temperature increases further. So I think it is somewhere between 15 to 30 degrees Celsius initially, and even more than that as you go further in inside the earth. How to switch from high to normal pressure immediately? It's not switching, but just that the lower part of the plant is maintained at high pressure. There is a pressure valve that will be used for pressurizing that part, and the vessel, the flash tank above it is at normal pressure. So we don't switch, just that the two parts are maintained at different pressures. For being better fuel, flash point should be low or high? For being better fuel, see, being better fuel is nothing to do with the flash point, just that with higher flash point, the fuel becomes safer because it does not ignite that easily. If I don't have any questions, may I leave? Yes, absolutely, you can. Kindly explain the process of biodiesel production. So biodiesel production basically happens from oil seeds, and from the oil seeds we undergo a chemical process called as esterification, where formation of esters happen, and from there on we see that it basically can be created. I think you should interact with students more often. See, depends on chapter to chapter. In this chapter, this is a very factual chapter as compared to many others. So the scope is very limited. In space technology, the scope was much better, and same will happen with some of the upcoming lectures as well. So depends on the chapter. You said that the origin of petroleum is underwater, then how is it available in the desert of Dubai? Because origin was underwater millions of years back. It was not desert then. I hope you have read geography. So some of you are saying that space policy is not there in the PDF. I'll check with the team because I had instructed them that towards the end of the PDF of the class, they should have given it. Why Kerala is not ideal location? No, Kerala is good enough location. Just that it's not there in the list of the top five. But Kerala is also a good enough place for wind energy production. GMO basically is genetically modified organisms. We'll understand that better when we go to biotechnology portion. There we'll discuss this. The leaderboard for today. The leaderboard. Yeah. So this is the leaderboard for today's class. Can you please tell where do you get all the blogs that you show us while teaching? No, these are not blogs. These are newspaper clippings. I mean, the news articles taken from various important websites. So some of them have been taken from the Hindu, from Indian Express, from Financial Express, from Down to Earth magazine. So wherever something appropriate regarding current affairs of these areas have been published, I've taken those newspaper clippings from there, or I mean, the news clippings from there. So these are not blog posts actually. So these are all the people who are in the leaderboard. Congratulations to all of you. Bio CNG will discuss tomorrow. Don't worry. Capacitor diagram in PPTs. We don't even need it. I just showed you because you had asked. Otherwise, it's not required at all. So I don't want it to be a part of the PPT. Otherwise, everybody will try to revise it, and it's not something that anyone would understand. Can geothermal energy be tapped at any hot springs in the country? Yes, a lot of them. There are a lot of hot springs in India, which basically we are considering for this. So, absolutely yes. Does biomass include human excrete also? Yes, we can include it, of course. Any example of municipal waste? Municipal waste is anything, I mean, that is collected by the municipality. So, a lot of organic waste from our domestic waste and everything from the domestic households, etc., they'll all contribute to the municipal waste. All right. So that is it for today's class. Please go back and revise. There are a lot of facts in this classroom, a lot of data, etc., that we have used. So please go back and go through them. And if you have any doubts, we can discuss that further tomorrow. Right. So this is the end of today's class. We'll meet back tomorrow. We'll finish this portion of biofuels, and then we'll move on to nuclear energy in tomorrow's class. Thank you.